Hello everyone, my name is David Tucker and welcome to the course Understanding AWS Core Services. I'm a cloud consultant that helps organizations plan, build, and implement custom software solutions in the cloud. I have over 15 years of experience in software architecture and development, and during that time, few things have fundamentally changed computing like the cloud. AWS certifications add value for both technical and non-technical resources in today's digital world. In this course, I will walk you through the services from AWS that you will need to know before you take the AWS Certified Cloud Practitioner exam. First, I will review the ways that you interact with AWS services. And next, I will review the major categories, including compute, networking and content delivery, file storage, databases, app integration, and management and governance services. And finally, I will provide an approach for preparing for the certification exam. When you finish this course, you will have a clear understanding of these core services, whether you want to take the AWS Certified Cloud Practitioner exam or just have a better understanding of the services that AWS provides. Welcome to Understanding AWS Core Services. My name is David Tucker, and I'm taking you here on a journey to get ready for your Cloud Practitioner exam. Now, this is the second of 4 video courses designed to get you ready for the exam. So hopefully by this point, you've already had a chance to go through the Fundamental Concepts course. Now, we're going to be diving deep and understanding many of the AWS services that are covered on the exam. But this is a lot of information to remember. So we've provided 2 different study resources for you here with this course. First, let's talk about how you get those study resources. Go in your browser to this particular course. Click on the Exercise Files tab and then download the zip file to your computer. If you look under the Module 2 directory, you'll find 2 different sets of study resources. First, you're going to have the guided notes. Now, these guided notes are designed to be printed out, and you actually write in the content as you go through it in this video course. And just in case you missed something, we've also included a completed version of the guided notes. Now, this is designed to help you as you're going through the video content, but it's also a great study guide to go back and visit as you're getting ready for the exam. But we haven't just included that. We've also included the first of 2 lists of AWS services with simple, easy to understand definitions, and you can use this as another study guide. A matter of fact, I recommend you actually look at this right before you go in and take the exam. So those can be found utilizing the Exercise Files tab in this course. Now, I'm excited to continue with you on this journey to you becoming an AWS Certified Cloud Practitioner. So now that we have a good understanding of AWS as a whole, we're going to be looking at how we leverage the services that are included within the platform. And when we're talking about interacting with those services, we're really looking at 3 different approaches. The first of these is the AWS console. And we used this when we set up our initial AWS account in a previous course within this path. Now, in addition to that, we also have the AWS CLI or command line interface. And this is what allows you to access those same AWS services, but just from the command line on your machine. Now, if you want to program access to your AWS resources, this is when you would look to leverage the AWS SDK, which is supported across a variety of languages. Now, let's take a look at each of these in turn. First of all, we have the AWS Management Console, and as I mentioned, we have used the browser version of this earlier in this path, but there also is a mobile application that goes along with this. Now, it provides access to most all of the 150 plus AWS services, and in this case, all major browsers and mobile operating systems are supported. Now, you'll probably primarily use the web-based interface, but it wouldn't hurt to download the mobile version and explore that on your own. So here's an example of the browser version of the console. We can see here that we're logged in. I'm logged in as myself, and we can see that I'm using the Northern Virginia region. And you can see a list of some recently visited services that I have had here on this version of the console. Now we'll dive into the console later on within this module. So next we have the AWS Command Line Interface or CLI. And this is a tool that allows you to manage your services from the command line. And this works on Windows, Mac, and Linux. And most everything you could do in the browser with the console, you can do with the CLI. So as an example, if we wanted to list the current users for our specific AWS account. We could run AWS IAM list users. Now, for those of you that maybe have some experience with the platform, you're noting that this is just limited to IAM users and not the root user, which is totally true, and we'll cover more of that in a later course within this path. Now, the next thing we have is the AWS Software Developer Kit, or SDK. And this is what allows us to use a programming language to actually script the process of how we interact with AWS. Now, this is great because it can allow us to automate many things within the platform. And as we look at the different languages that are supported, we do have quite a range here. And this includes Java, .NET, Node.js, JavaScript in the browser, PHP, Python, as well as Ruby, Go, and C++. So for most developers, you're working in one of these languages, and that is supported with an AWS SDK. Now let's talk about when you would use one of these approaches versus another. So first of all, the console is a great method for testing out AWS services. So if you want to leverage a service for the first time, if you want to spin up a virtual server and maybe you haven't used EC2 before, or maybe you're looking at testing out a new service that AWS just announced, the console is a great way to do this. However, if you have repeated tasks, you might want to look at using either the CLI or the SDK. If we require a person to log into their browser and go and perform tasks, that can be very cumbersome. But if we're going to be doing these tasks continually, this becomes a great case for automation. And both the CLI and SDK can enable that automation. Now next, the SDK enables automation of AWS tasks within custom applications. So if you have a custom application that you're running on AWS, and you want it to automate some way of interacting with an AWS service, the SDK becomes a great choice for that. Now it's important to note here, most all services and actions can be performed in any of these three. Now there are some exceptions to that rule, and we'll cover a few of those within this course, but at a high level, just know that for most services, you'll be able to use either the console or the CLI or the SDK to perform whatever tasks you need when using these services. So now we're going to dive in and actually use the AWS console. Now, you may have seen this already earlier within this learning path, but we'll take some time to analyze some specifics of the console. And it's important to note here, we can refer to the console either as the browser or the mobile app, but in this case, we're going to be working specifically with the browser version. So first of all, here in this demo, we are going to be accessing the AWS console in the browser. We'll also be reviewing the login differences for both root and IAM users. We'll also look at selecting a specific region and reviewing the list of services that are supported in the AWS console. So I'm here at the login page for the AWS console, and here I'm going to be logging in as a root user. Now, this is different from an IAM user. We will cover IAM users later within this learning path, but there are some distinct differences between these two types of accounts. First of all, your root user is the user that was created when you created your AWS account. And there are some things that you can generally only do with the root account, such as deleting the account. Now, recently, AWS has provided another way to do this, but in many cases, if you're just starting out, you'll be using this if you need to go in and delete that account. So from here, I'm going to go ahead and enter in my root user email address. Then I'll go ahead and go to next. I'll enter in my password. And now I'll sign in. So now I'm here in the console, and I want to call out a few things to start with. So first of all, in the top right, I can see the name of my account, and I can see the account information. And this will include all the information around my account, my billing dashboard, and things like my security credentials. And right next to it, I have another drop-down. And this is the drop-down where I select the region that I'm working in. Now, currently, I have selected US East 2, and that means that any resources that I actually create while I'm using the AWS console will be created within the US East Ohio region. Now, I can change the region that I'm using by simply selecting another region. By selecting Northern Virginia, I'll now switch all resources that I'll be creating over to the US East 1 or Northern Virginia region. Now next, we can take a look at the different AWS services that we can create using the console. So I'm going to click on the option here under Services, and we will see that we now have a pop-up here that shows us all of the different services that are divided by categories. If I want to launch a compute service, for example, I can select Compute and then determine which service I want to use. If I wanted to spin up a Lambda function, I could simply click on Lambda. By doing that, that would navigate me to Lambda here within the console, and then I could choose to go in and actually create a function. But we don't have to just navigate in this way. I'm going to look for another service specifically, and I'm going to do this by going under the search box and by just typing Route 53. And just by typing route, you can see that it suggests Route 53 as an option. So from here, I can click on this service, and this will open up Route 53. Now, there's one of the things I want to point out about this service. This is AWS's DNS service, and you'll notice that it is different from the other services that we've looked at in that it is a global service. You don't select a region when working within Route 53. And there are just a small handful of services that fit into this overall category. Now, there's one other thing I want to point out because I think this is very important if you have your own AWS account. So here, I'm going to go under my account name, and I'm going to go down to the option that says Security Credentials. Now, this is where you would go in and do one of several things. One, you can choose to update your password from this portion of the console. You also can enable multi-factor authentication, which is something that is a recommended best practice for all root accounts. Now, in doing this, you can utilize some type of an authenticator application to generate a unique code, and you will be required to enter that code along with your password when you log into the AWS console. Now, another thing that you can do here is you can generate access keys, and these access keys can let you access the different AWS APIs, either using tools like the CLI or the SDK. And that's what we'll be picking up in the next demo. So now we're going to discuss the AWS CLI. Now, as a note here for the exam, you need to know what the CLI is and why you would use it. You don't need to actually have experience working with the CLI directly, but I do want you to see what you can accomplish utilizing the tool. So here in this demo, we're first going to be looking at how we can access our AWS access keys for our account. We also will be reviewing installation instructions for the AWS CLI. We will look at how we can configure the AWS CLI for a specific user, and we will be interacting with AWS utilizing the Cloud Shell CLI from our browser. So now I'm here where we left off in the last demo, under security credentials for my account. Now, if you don't remember how to get here, when you log into the console, you can simply click on the account name, and from here you can go down to security credentials. Now, we talked briefly about access keys. Now, access keys are one way that you can get access to utilize either the CLI or the SDK. Because in both cases, AWS needs to make sure that you are a user that has permission to perform whatever action it is that you're trying to perform. Now, one of the things about access keys here is you will see a warning if you try to create an access key while you are a root user. It does tell you that root user access keys provide unrestricted access to your entire AWS account. They suggest if you need long-term access keys to create an IAM user with limited permissions and generate access keys for that user instead. And this is obviously good advice. We don't want to go in and create these keys that can do anything for our account. Now, I'm going to show you how to generate access keys here under the root user, just so you know how to do it for your user. But again, we would recommend not doing that for the root user and keeping those keys around. Now, as another note, as soon as I create these access keys, I will be deleting them as soon as this demo is over. So I'm going to go ahead and hit the option to create new access keys, and it tells me here that it has been created successfully. Now, here's the thing about access keys. You only get to see this information once. You can download a key file, which will save this on your hard drive so that you can access what those values are. You also can see them here.
But if I click Show Access Key, this information won't be available to me later. If I want to utilize this access key, I need to get this information now. Now, anytime I utilize the CLI or I want to utilize the SDK, I can use these values to help make sure that it actually is associating it with my user and giving me permissions to do what I have permissions to do on AWS. Now, if I wanted to use this with the CLI, I would need to install the CLI on my machine. So here, I'm going to show you in the next tab on the browser, the instructions for installing the AWS CLI or Command Line Interface version 2. So here, if I scroll down, you can see that we're able to get access to an installer that will work for a lot of different systems. We have Linux as well as Mac and Windows. I'm on a Mac, and I would look here at the installation instructions utilizing the installer that they've provided. So in this case, I could simply click on this file, download it to my machine, and run it, and I would have the CLI installed. Then I could go through the process of configuring it for my specific user. However, wouldn't it be great if there was a way that I could just from the console launch the CLI and it already knew who I was and already knew what permissions I had on AWS? Well, we can actually do that utilizing a feature called Cloud Shell. So instead of me downloading this and installing it on my machine, which as a note, I already have it installed on my machine because I use the AWS CLI on a regular basis. But instead of that, we can get up and going faster with the CLI utilizing the Cloud Shell. So I'm going to click the browser tab to go back here to the console. Now I'm going to close out these access keys and I'm actually going to delete them here. And it's letting me know I first have to deactivate them. So I will deactivate them. And then I will confirm deletion. So now I've deleted those access keys. Now here from the top, I'm going to go under Cloud Shell. And this lets me know here that I can utilize Cloud Shell here within the browser just like I was using it on my local machine. And it utilizes some pre-installed tools, and it also includes some free storage that I can use. So as long as I'm working within the same region, which in this case is Northern Virginia, anything I have saved on this instance that's running the Cloud Shell, I can access that information later as well. So I'm going to go ahead and hit close. Now the first thing I want to show you is that it does have the AWS CLI installed. So I can simply type AWS --version, and I can see that I'm running version 2.9.4 of the AWS CLI. I also want to show you that I can actually perform actions on my AWS account here from the CLI. So here, I'm going to run a command that's going to create an S3 bucket. Now, I know we haven't talked a lot about S3 yet. Don't worry, we'll be getting to that later within this course. But when I hit enter, it's going to return and say, this was successful. We have created your S3 bucket. Now, I can verify that that is correct by listing all the S3 buckets that I have in my account. And here you can see it returns the name of the bucket I just created. So let's talk about what we've been able to cover in this demo. First of all, we looked at how we would create different credentials that we could use to access either the CLI or the SDK, and it would know what user we are and what we have permissions to do. We also had a chance to go through and look at how we would install the CLI on our local machines if we wanted to do that. And then we launched AWS Cloud Shell, which lets us interact with the CLI just within our browser. And it already knows what user we are and what permissions we have. So we were able to execute a command, in this case, creating an S3 bucket, and then verify that it worked correctly.
So next, we're going to help you gauge how well you understand the material that has been presented in this module by looking at 3 different scenarios. Now, we're going to take time and review each of these scenarios here within this clip. Be sure in your guided outline to write down the notes about what you think the answer is for each scenario. And in the next clip, we will be walking through the answers to each scenario. So here's our first one. We're going to start off with Roger, and his company runs several production workloads in AWS. Now they have a new web application that manages digital assets for their marketing team. And what they want to do is they want to automatically create a user account in Amazon Cognito when the user signs up through their custom application. Now, in this case, Amazon Cognito we haven't covered yet, but it is basically a user directory for our custom applications. And what they want is they want this to seamlessly integrate into the application that they have. And the application that they have is a React-based web application that actually has some microservices on the back end that are written in Node.js. So, in this case, which interaction method would Roger's company use for this? Now next, we're going to look at Eliza, and her company is considering moving to AWS. And they want to leverage a service called Amazon Relational Database Service. And she just wants to test out a single database on the service. Now, she hasn't ever used it before, so she just wants to get in and understand how it works. So in this case, what interaction method would Eliza use for this use case? Okay, next we're going to look at Jennifer, and her company is a startup. And they created a social network for entrepreneurs that has both a web and a mobile app. Now, she has a set of tasks that she needs to run each day to help generate some reports on usage. So in her case, what interaction method would she use for this use case? So in the next clip, we'll run through and look at the answers. So before we dive in and take a look at the different scenarios that were presented in the previous clip, let's take a minute and look back at what we have covered in this initial module in this course. First of all, we reviewed the ways you interact with AWS services. We talked about leveraging the console, the CLI, and the SDKs. We then looked specifically at the AWS console and its use. We even went through a demo to highlight key areas of the console. Now with this as well, we talked about the fact that the console is primarily a browser-based experience, but there also is a mobile application that you can leverage. We then introduced the AWS command line interface, or CLI, and its use. We also did a quick demo to showcase how you would configure the CLI with your credentials. Then we introduced the AWS software developer kits, and we talked through the different programming languages that are supported with the SDKs. Now, let's take a look at our scenario. Here, in this first scenario, we talked about Roger, and he wanted to seamlessly integrate Amazon Cognito into his custom application. Well, in this case, the solution is going to be the SDK, or software developer kit. Now, the reason is because Roger wants to bake this into his custom application. So because he wants to bake it into his custom application, and if you remember, we talked about some backend services that were using Node.js. In this case, he can choose to leverage the SDK for Node.js to interact with Amazon Cognito within his web application. So that's scenario one. Let's look next at scenario two. And we were talking about Eliza, and she wanted to leverage Amazon Relational Database Service, or RDS. What should she use? Well, in this case, using the AWS console makes sense. Eliza is not looking to automate this. She's not looking to create this for production. She just wants to get in and use the service and understand how it works. So this seems to be a great fit for using the console. Next, let's look at Jennifer. And when we were talking about Jennifer's specific scenario, she had tasks that she performs on a daily basis that she needs to utilize something to automate. And so what interaction method would she use? Well, in this case, we're going to say the CLI. However, you could also say the SDK in this case. She could build it out either way. But what she doesn't need to do is go in and perform the same tasks in the console day in and day out. There's a more efficient way to do it using one of the two different approaches for automation, either the CLI, where she could write a custom script to do these things for her, or bake it into a custom application utilizing one of the supported programming languages with the SDK. So next, we're going to be talking through compute services on AWS, and we're going to be focused on the compute services that will be covered in the Certified Cloud Practitioner exam. Now, at a high level, a compute service is just a service that enables you to leverage cloud-based virtual machines for your workloads. And this could be a lot of different things, running a database, having a web server, or data processing. Now, we're going to primarily be talking about three different compute services on AWS. First, we're going to be looking at Amazon EC2, which is a foundational core service on AWS. And this is what enables us to run virtual servers on AWS. Then we'll be looking at Elastic Beanstalk, which is a platform. So this is platform as a service for scaling and deploying web apps and services. And then we're going to be looking at AWS Lambda, which enables compute, but without having to manage any servers. So here's what we're going to be covering. First of all, we're going to be introducing Amazon EC2 capabilities. And then alongside that, we'll be exploring the different pricing approaches for EC2 instances because there are a lot of options to consider here. Then we'll be introducing the capabilities of AWS Elastic Beanstalk and then reviewing use cases for Elastic Beanstalk. And finally, we'll be introducing AWS Lambda. So next, we're going to talk about Amazon EC2. And Amazon EC2 is one of the fundamental core services of AWS. And AWS defines it as a web service that provides resizable compute capacity in the cloud. And it's designed to make web-scale computing easier for developers. So before we get too deep into EC2, let's look at some sample use cases where we could choose to use EC2. Let's say, for example, that we want to host a web application in the cloud. We could choose to spin up an EC2 instance, and then on that instance, we could install a web server. And then on that web server, we could go in and put the files for our web application. So in that case, EC2 would totally meet that need. But we also could do things like batch processing of data. So if your organization produces maybe 1 million rows of point of sale data each day and you want to pull that in and do some pre-processing before you analyze it, you could use an EC2 server for that. You could also use it to just be an API server where you take web services and launch them in the cloud and let other applications access them. Or you could do something like even having a desktop in the cloud. So if you want to launch a Windows instance on Amazon EC2 and then be able to connect to that through remote desktop, all of those things are possible utilizing Amazon EC2. Now next, we're going to talk about the core concepts that we need to know before we are able to launch an EC2 instance in the cloud. First, we need to understand instance types, and then we need to understand root device type. Next, we're going to look at the Amazon Machine Image, or AMI, and then we're going to look at the different purchase options for EC2 instances. But let's start off by looking at instance types. So an EC2 instance type defines the processor, memory, and storage that are available to any servers that are launched with that instance type. And you can't change this without downtime. So if you've launched an EC2 instance, which is your virtual server, and it has a certain amount of memory based on the instance type that you chose when you launched it, you can't simply go to that server and say, I want to put a new instance type in. So we do want to make sure that we make good choices on instance types when we launch them. Now we have instance types across several different categories, including general purpose. So for most workloads that you're going to put in the cloud, general purpose will probably work fine for you. But we also have compute, memory, and storage optimized instance types. And again, that's 3 separate categories there. So for example, if we wanted to launch an in-memory database on our EC2 instance, we might choose a memory optimized instance type. But we also have accelerated computing. And these are for specialized use cases. For example, machine learning, because in this case, with those instance types, you could get access to a GPU, for example, which could be very important for the different machine learning work that you're doing. Now, pricing is based on the instance type. So if you choose something that has more resources available to it and it's a specialized type, it will cost more than just using a general purpose instance. But some instance types also have unique capabilities. So some families of instance types have access to things like specialized storage or GPUs, as we mentioned earlier. So next, we're going to look at some sample EC2 instance type pricing. Now I need to make a couple of caveats here. One is that EC2 pricing changes over time. So these numbers might not be accurate in the future. But in addition to that, the prices can also change from region to region. So let's just use these prices I'm showing here, even though I pulled them from US East 1. Let's just use them to help us understand relatively what different instance types cost. So I'm going to start off here with a couple of different general purpose instance types. You can see here that we have a T3 medium and an M5 large. Well, we can see that the M5 large has twice as many virtual CPUs and 4 times as much memory. And in this case, it's just a little over twice as much per hour. In this case, coming out to be just a little bit under 10 cents per hour. Now here is an example of a compute optimized instance type, a C5D24X large. We can see here that we have a dramatic jump in all 3 categories, virtual CPUs, memory, and pricing, with this coming out to be about $4.60 per hour. But then we have a P316X large. Now this is a very specialized instance type that comes from the accelerated computing category, because this gives us access to some of the industry-leading GPUs for things like our machine learning workflows. And in this case, this one comes out to be about $25 per hour. So even though it looks here like it has less virtual CPUs, this factors into some of those special capabilities that are included within the P3 instance type family. And then we have a storage optimized instance type, an i3-16X large, which again has 64 virtual CPUs and a lot of memory, and it comes out to be about $5 per hour, but it has some special access to storage capabilities that the other instance types don't have. Now next, let's move away from instance types and let's take a look at the root device type. There really are two different root device types that you need to know when working with EC2. The first is what we call the instance store, which is ephemeral storage, and it is actually physically attached to the host that the virtual server is running on. So that's one type. And the next type is elastic block store, or EBS, which is persistent storage that exists separately from the host that the virtual server is running on. Now, when EC2 initially launched, we just had instance store, but now that we have EBS, I'll go ahead and tell you that for most work you're going to do on EC2, you want to use elastic block store, which is EBS, unless you have a specific reason not to. It provides a lot of capabilities that will help you, but one of the key differences is the difference between the words ephemeral and persistent. So with an instance store, if you spin up your EC2 server and you actually completely shut it down, then the data on that instance store will go away. However, EBS data will be persistent, and we can even go in and take snapshots of it and copy it and launch new EC2 instances with EBS volumes. There's a lot that we can do, and we'll cover that more later within this course when we talk about the different storage services that are available on AWS. But just know here that instance store is ephemeral, meaning that if you shut down the server, that data will go away, and EBS data is persistent, meaning that if you shut down the server, that data is still there. Now let's look next at Amazon Machine Images, or AMIs. Now, I should probably also mention here that there is fierce debate amongst the AWS community on whether or not this is pronounced AMI or AMI, but in this case, you'll hear me refer to it as an AMI. But just know if you hear somebody else refer to it as an AMI, that's what they're referring to. Now, an AMI is a template for an EC2 instance that includes configuration, the operating system, and the data that actually would go on that specific instance. And AWS provides many different AMIs that you can leverage. And when we go through actually using EC2 later within this module, you'll see that there are several provided by AWS that are relatively easy to spin up a new instance from. But AMIs can also be shared across accounts. So if your organization has a specific version of, let's say, Ubuntu Linux that you want to modify in a certain way for security purposes, and you want to have it be just exactly the specific way, and you want it to have one extra drive that's attached where you store other pieces of data, those are all examples of configurations that you can make within an Amazon machine image. And as I mentioned, you can create your own custom AMIs, and there also is a marketplace for commercial AMIs. So if you want to use AWS Marketplace, you can go and explore the different AMIs that are provided from commercial vendors. So now we're going to talk through the different purchase types that you get when you're working with EC2. So first of all, we have on demand. And if you just launch an instance by default, this is what you're going to get. We then have the option for reserved instances. Then we have savings plans, which was a newer option. Then we have spot instances and dedicated host instances. So let's understand each of these options and when you would want to use them. So first of all, we have reserved instances. And what this does is this provides discounts over that on-demand model, which again is going to be your default model, when you can commit to a specific period of time, which is going to be 1 or 3 years. In addition, it also provides a capacity reservation for the specific instance type that you specify. So you can make sure that when you go to launch that, that's going to be there for the entire period of time that you sign up for. Now, within reserved instances, there are multiple types. And let's quickly review these. Now, as a note here, you're not going to need to dive super deep into each of these for the exam, but I do think it's important to understand the different approaches that you can take. So first, we have standard. And this gives you the highest discount, and it works well for steady workloads. But if you have a standard reserved instance, what that means is that if you want to get a bigger instance type, you can't make that change. You're locked in for that period of either 1 or 3 years. And that's why we have a convertible reserved instance. And with this does allow us to convert some of the attributes if it's going to be of equal value to what we already have. This is also great for steady workloads. Now, in some situations, you're going to have predictable but not steady workloads. And if that's the case, you can create a scheduled reserved instance. So this is able to have a time window attached to it. And so if you know, for example, that during weekdays for a specific period of time, you're going to have a lot of usage and you want to get a reserved instance for that, the scheduled type would work well. Now let's look at just the standard reserved instance cost model. So with this, you have some choices. You can specify that you want to pay this all upfront. So you can say if it's 1 or 3 years, you want to pay all of it. And this is going to give you the highest level of savings, but it's also going to require the biggest upfront investment for that instance. You can then do a partial upfront, and this is going to enable you to pay part of that 1 or 3 year period upfront, and then you'll have a reduced monthly cost. But even if you don't choose either of those, if you take a no upfront approach, you're not going to have to pay anything upfront, but you'll still get a reduced monthly cost over the on-demand option. So here's the way to look at it. Here on the far left, we have the maximum savings, and on the far right, we have the minimum upfront cost. So you need to be able to evaluate a situation and determine which of these would make the most sense. Now next, we have the option that is the savings plans option. Now this is very similar in concept to reserve instances, but one of the key differences is that it's not just limited to EC2. It supports compute with EC2, Fargate, and AWS Lambda. But unlike reserved instances, it does not reserve capacity. Now, that being said, there's still a way you can reserve capacity with savings, but it's going to be in addition to what you do with savings plans. And it can provide savings of up to 72%. And just as with reserved instances, it comes in 1 or 3 year terms. However, if you want to get the biggest price reduction, you can look at spot instances. And this really enables you to leverage the excess EC2 compute capacity that might exist within an availability zone. So let's quickly look at some notes here on spot instances. First of all, it can provide up to 90% in discounts over on-demand pricing. Now with this, there is a market price for instance types per availability zone, and this is called the spot price. So think of this almost like a stock market for excess compute capacity. Now, when you request instances, if your bid is higher than the spot price, then you'll be able to launch your instances. Now, if the spot price grows to exceed your bid, then your instance is going to be terminated. Now, it's not instant. You do get 2 minutes prior to termination. However, what this means is this will only work for workloads that can start and stop without affecting what you're trying to do. So if that's your use case, you can get great savings by using spot instances. Next, we have the dedicated host option, and this gives you a dedicated physical server in the data center. Now, this is going to be your most expensive option, but there's 2 use cases that you need to know that would require this approach. The first is going to be if you have a per server licensing model and you want to be sure you're abiding by the terms of that license. In that case, you'll need to use this option. Also, for some compliance requirements, it requires that you utilize a dedicated host. And if that's the case, you'll also need to use this pricing model. So let's quickly review the different options. First of all, if you have an instance that is consistent and always needed, you should purchase a standard or convertible reserved instance. Next, if you have batch processing where you can start and stop without affecting the overall job, this is where you should look to leverage spot instances because this is going to give you the maximum savings. So next, if you have an inconsistent need for instances and you can't stop it without affecting the overall job, this is where you want to look at just the standard on-demand instances. Now, a few other notes here. If you have specific per server licensing, or if you have a compliance requirement for a dedicated server, you should use dedicated host. And also here, if you're leveraging Lambda and or Fargate alongside EC2 and want to achieve discounts for a 1 or 3 year period, this is where you can choose a savings plan. But if you have predictable but not steady workloads in EC2, you should purchase a scheduled reserved instance. Now let's look at some examples specific to reserved instances. So first, let's say that we have a T3 medium. So we can see here it's a little over 4 cents per hour. Now, if we look to purchase an EC2 reserved instance, if we do all upfront for 1 year, we pay $213. If we look at the effective hourly rate, that's going to be about 2.4 cents. That's going to save us about $150. And if we look at the same thing for 3 years, we're going to have the ability to save over $680. So here, our savings are only going to increase as we move to bigger instance types. So here, if we look at a compute optimized instance like a C5D 24X large, the on-demand rate is going to be $4.60, almost 61 cents per hour. Now, if we look here at just a partial upfront for only a year, what we're going to do is we're going to pay $12,000 plus a little bit more upfront, and then we're going to pay about $1,000 monthly. What this does is this lowers the effective hourly rate to $2.76 and a little bit more per hour. That gives us about 40% savings. We can look also here at an i3 16X large. We can see here that the on-demand rate is almost $5, and we're able to achieve 52% savings. So even though the cost is high here, if you need this specific instance type, this approach is going to give you a lot of savings if you can commit to the 1 or 3 year period. Now, if we look here at spot instances, this is where we're going to see even more savings. So let's take a look at our T3 medium that we mentioned earlier. So on demand is going to be about 4 cents per hour. And with spot pricing, we could see this get down to maybe a little bit over 1 cent per hour. Now, as a reminder, this is a market price. So this is going to change. This is when I was actually looking at the pricing when I was creating this course. Here's what you could get this for. You can see here, this is going to give us about 70% savings. Now we can also look at our C5D 24X large. Here we're going to see 80% savings. And we also could see 70% if we're looking at our i3 16X large. So you can see here that there are huge benefits to exploring the different pricing models that you can leverage with Amazon EC2. Next, you'll need to know the information that we have covered thus far about EC2 for the exam. You don't actually need to know how to launch an EC2 instance utilizing the console, but I want to show you that so you better understand how you'll see some of these concepts in play if you're using AWS. So here within this demo, we're first going to be launching a new EC2 instance based on an AWS AMI. We'll then be exploring the EC2 launch wizard in the AWS console. We'll be configuring an EC2 instance to be used as a web server. And finally, we will be terminating an EC2 instance. So let's dive in. So I'm here in the AWS console, and I'm going to go up to the search bar, and I'm going to search for EC2. I can see the service here, so I'll click to go to EC2. From here on the EC2 page, I can get a summary of the resources that are currently running. But if I scroll down, you can see that I have the option to launch a new instance. If I click on that, I've got the option in the drop-down menu to launch an instance, so that's what I'm going to select. Now first, we get an opportunity here to specify a name. Now in this case, I'm just going to call this my test web server. And we're actually going to be running a web server here. Now, with this being said, we're just going to show the test page. We're not going to do anything else with it, but this will help illustrate how you can actually launch real infrastructure in the cloud with Amazon EC2. Now next, I want you to see that we're only launching one instance. Now, in many cases, that's all you would need, but there are scenarios where you might want to launch 2, 5, or 10 instances at a time. Now, I'm going to scroll down from here, and the next option that I have is to select the AMI or Amazon Machine Image. We currently have selected the Amazon Linux 2 AMI, which is free tier eligible, and that's what we're going to use. But I want to show you how you could look at the other AMIs that are available. So from here, I get to see different categories of AMIs. First, we have the Quick Start AMIs. When you're getting started, this will generally be where you select the AMI from. But we also have options like Community AMIs, and these are published by different people using AWS who want to make their AMIs available outside of their account. We also have the AWS Marketplace AMIs. Now, as an important note, some of these AMIs will have an additional charge to utilize them, so be sure you understand all of the terms of using that AMI before you select it. And then we also have My AMIs, so we can build up our own AMIs and then save them for later use. But in this case, we'll keep the one selected here, which is the Amazon Linux 2 AMI. And as I noted earlier, it is free tier eligible.
Now that I have that selected, I'll scroll down, and my next option here is instance type. Now I'm also going to keep the default one here, which is a T2 micro, and it too is free tier eligible. But I could open up here the dialog to see all of the different instance types. And you can see here in this region, I have 606 different instance types that I can pick from. And I could choose to go through and sort based off of memory, for example. So if I wanted to see the one that has the most memory, or I could go through and search on vCPUs to see the ones that have the most. But as a note here, we want to stick with the ones that are free tier eligible. So from here, I'm just going to hit cancel, and we'll see that T2 micro is indeed still selected. Now next, you'll have to pick a key pair. This is a required step. Now we're not going to be using it in this demo, but you still have to pick one. I already have one set up, but you could choose to create your own by simply selecting the option that says create new key pair. This basically is your kind of password for being able to log into this server to administer it. It's actually more than a password, but in this case, you can just save it to your local machine and you can go back and use it later. But I'm just going to select the one I already have. I'll look down under network settings. We haven't yet talked about VPCs, so I'm just going to keep all the default values here for network and for subnet. But I do want to make a few changes here under where it says firewall security groups. So here we want to make sure that the only people that can log in and administer this server are the ones that should be logging into it. So in this case, I'm going to say, you know what? I only want my IP address to be able to log into this server via SSH, which is how we would administer this server. But I also want to select another option. Since we're dealing with a web server here, I want to specify that I want to allow HTTP traffic from the internet, meaning anyone on the whole internet can access my web server. And that's generally what you would want to do if you had a web server. Now I'm going to scroll down here and we'll leave the default values for storage. In this case, we have 8 gigabytes on a GP2 volume. Now, if I look here, you see that we can choose from different volume types, like a provisioned IOPS SSD, for example. But we'll just keep the default value here, and you can see there is a note that this will be free tier eligible. Now, I'm going to open up the option here for advanced details. You'll see a lot of things here that we can select, including requesting spot instances. But we're not going to do that here. We will keep this as an on-demand instance, but I'm going to scroll all the way to the bottom, and it gives us the option to enter in what they call user data. Now, really, these are just commands that the server is going to run as it launches. And here, I'm going to give it just a few commands so that it is able to install and start a web server. Now, don't worry if you don't understand this. This in no way is going to be covered on the exam, but I simply wanted to use this as an opportunity to show you what you could do as you launch an EC2 instance. So now I'll hit Launch Instance. From here, you can see it's taking different steps that are required to get our instance up and running. Once those steps are complete, you can see that we have a name here for this particular instance. So I'm going to click on this identifier, and we can see here that the current instance state for our test web server is pending. But we need to wait just a minute for it to finalize the initialization process. But I'm going to go ahead and select it, and we can see when we do select it, we have some additional information that's available about our instance. And one of the things that we'll see is the public IPv4 DNS. And what this is the domain name in essence for the server that we've just launched. So I'm going to click on the option here that says copy. Now that I have this copied, I'm going to go in and I'm going to open up a new tab. And from here, I'm going to type in HTTP and the domain name that we've just specified. And then I'm going to hit enter. And we can see here that we do have the test page for our web server. So now this is being served from the web server that we launched within our account. Now I'm going to go back to the instances that I currently have running. There's one more thing we need to do. We usually don't want to keep an instance up and running for no reason. So here we're going to need to terminate this instance. So with my test web server selected, I'm going to go under instance state and I'm going to terminate the instance. And here it's going to tell us that this is going to delete the EBS volume when we delete the server, and that is indeed what we want, so we will click on terminate. So here, you have been able to successfully launch a virtual machine in the cloud with Amazon EC2. You have set it up as a web server, you've actually verified that it can receive traffic, and now we've gone through the process of deleting it.
So up to this point, we've been focusing on Amazon EC2. But now we're going to look at a different compute option that is available on the platform, and that is AWS Elastic Beanstalk. So at a high level, Elastic Beanstalk automates the process of deploying and scaling your workloads on EC2. But the difference is, instead of dealing with those servers directly, which we would call infrastructure as a service, this is more of a platform as a service type approach. Now, because of that, it does support a specific set of technologies. So unlike EC2, where you can really do anything you want, as long as you can get it up and running on a server, you can do that on EC2. Here, Elastic Beanstalk works within a set of technologies. Now, it does leverage existing AWS services, and you only pay for the other services that you leverage. And so this brings up kind of a new category of services for us on AWS. And these are services that really just make it easier to use other AWS services. So in this case, we're still theoretically running all of our compute on EC2, but the process of managing those servers and handling things like provisioning and load balancing, scaling, and monitoring are all handled automatically through the work of Elastic Beanstalk by connecting other services into the overall platform. Now you might be asking, well, what platforms does it support? And that's a great question. So here we're going to be looking at a lot of the usual suspects here, like Java and .NET. We also have PHP and Node.js, as well as Python, Ruby, Go, and then interestingly enough, it also supports Docker. So the good thing here is, even if you weren't using one of these other platforms, but you still wanted to use Elastic Beanstalk, if you could configure a Docker container with whatever framework you wanted to leverage, you could still find a way to support it on Elastic Beanstalk, but with just a little bit of extra work. Now you might be saying, well, I get that, and I get that all of these different technologies are supported, but why would I choose Elastic Beanstalk? What are the features that it has that would be an advantage over using EC2 directly? Well, first of all, one of the great things about Elastic Beanstalk is it does have integrated monitoring included. And again, it's using other services that we'll talk about later to pull that monitoring information in. Now here, deployment is critical. You might just think, well, I'm just copying some files to a server. How hard can it be? But in reality, in production, deployments aren't that easy, especially when we're talking about load balanced environments and you're dealing with multiple servers and trying to figure out how to appropriately deploy things onto servers and make that available to end users, and Elastic Beanstalk manages all of that for us. In addition, it also handles scaling. So if we want to be sure that our web application that's used within our business as an internal application, if we know that there's going to be a huge demand upcoming, we can trust that Elastic Beanstalk is going to be able to handle that scaling appropriately. And we can add some configuration to that so that we can best handle upcoming demand. But it also allows for EC2 customization. So here is the one area where it kind of starts to maybe stretch beyond just a little bit the platform as a service approach. It does give you the ability to add some customizations to those servers that it's actually going to be running on. So why would you want to use Elastic Beanstalk? So if you want to deploy an application with minimal knowledge of other services, so let's say you know Elastic Beanstalk, but you're not familiar with really administering EC2 servers or auto-scaling groups or getting metrics from CloudWatch, setting scaling rules, these are things that you can simply rely on Elastic Beanstalk to do for you. In addition, if you want to reduce the overall maintenance needed for the application, this can be a great choice. So if you can fit into the specific use case that Elastic Beanstalk has, you can avoid having to deal with many of the other administrative tasks that are simply taken care of by the platform. In addition, this makes sense if you're not looking to completely customize the environment that you're in. If you say, well, I want to use this specific AMI and it has to have this specific package and I don't want it to upgrade to this other version of the package, you can get really specific about those things. If that's you, you probably want to look at using EC2 directly. But if you say, you know what, I really don't need to customize it, I can take what it gives me by default, then Elastic Beanstalk can be a great choice and one that will save you time, especially over the life of the application. So now that you have an understanding of what Elastic Beanstalk is, we're actually going to dive in and use the service. So here, over the course of this demo, we will be first accessing the sample Elastic Beanstalk applications, and these are included within the Elastic Beanstalk documentation. We will then be launching a sample application on Elastic Beanstalk, and finally, we will be deleting a deployed Elastic Beanstalk application. So let's dive in. So I'm here in the Elastic Beanstalk documentation, and you can find the specific link inside of the guided notes that you have for this course. But I'm going to scroll down here, and we actually can move past the tutorials down to where we have sample applications. Now I'm going to select this option that says Node.js, and it will download this file to my machine.
Now, this isn't the only way that you can create a sample application, but I want you to understand what goes into creating a deployable package and how to upload it for the service. So here, I'm going to go under the tab that has my console, and you can see that I'm already logged into the AWS console. I'm going to go up to the search bar, and I'm going to search for Elastic Beanstalk. I can see the service here, so I'm going to click on it. And from here, I'll select the option to create an application. I'm going to give it a name. And then I could choose to next go in and add tags. Now, I'm not going to add tags in this case, but as we've talked about earlier, tags can be essential in helping you to categorize the different costs that you have for the resources you have deployed in your AWS account. Next, under Platform, I'm going to choose Node.js. And here we can leave the default values. That should work just fine. Now here, as I said, this wasn't the only way you could create a sample application. I'm going to upload my own code here, but you could just choose the sample application and dive in. But in this case, I'm going to say that I will specify a local file. So here, I'm going to select our node.js.zip file that we downloaded from the documentation. And it says that it has successfully uploaded. And next, I'm ready to create the application. So I'll go ahead and click on that option. Now, it's important to note here, we've accepted many of the defaults that come with Elastic Beanstalk. There is a more advanced option where you can go in and configure just about anything you can imagine, including things like the instance type that your code is going to be running on. But in this case, I've chosen the option to just accept the defaults to get us through the creation process. And now we can see that our application has been launched with Elastic Beanstalk. Now, one of the first things I'll point out is we do have a link here, and you can see it utilizes the domain elasticbeanstalk.com, and this is going to be the URL for our application. So I'll click to open this in a new tab. And here we can see that our sample Node.js application is indeed running. So I'll go ahead and close this. We'll go back to the console. And you can see here that it's giving us just some high-level information about the events that we've had within this environment. But from here, I'm going to open up the left pane, and we're going to go look at our application. You can see here that we do have our configuration that we can take a look at. And as I mentioned earlier, we accepted the default values, but we can look in and see the specific instance type. We can look at our capacity. We can look at our load balancer configuration. We can look at how it handles deployments, security, monitoring, and all of these are utilizing multiple AWS services to help make this work. But the nice thing about using a platform as a service option like Elastic Beanstalk is you don't have to know all the specifics of how to integrate all of those services initially. We also have the ability to go in and look at logs. Here we could request logs from our instances that are running. We could evaluate the health of our instances. We could go in and look at monitoring. And again, we don't have a lot of monitoring data here because we just launched this application, but we also can go in and we can configure alarms, for example, in case we want to be notified when something happens and our application is not working as it should. Those are just a few of the different settings that we have. But now that we've created an application, just like anything in the cloud, if we're not using it anymore, we need to delete it. So I'm going to go under Actions, and here I'm going to say Terminate Environment. Now from here, I need to go in and enter the name of my environment, and then I can confirm that I want to terminate it. So now we've started the termination process. So here we've been able to take a sample application from the Elastic Beanstalk documentation, we've uploaded it as a part of the creation process, and we have created a new application and environment inside of Elastic Beanstalk, and then we've terminated it.
So now we have already talked through two of the three compute services that we said we would be covering in this module, and that would be Amazon EC2 and AWS Elastic Beanstalk. But now, in this clip, we're going to be introducing the third, which is AWS Lambda. Now, Lambda is different in that it lets you run code without provisioning or managing servers, and you only pay for the compute time that you consume. And so you can run code for pretty much any type of application or backend service, all with zero administration. So at a high level, AWS Lambda does enable you to run code without provisioning infrastructure, and as we said, it is only charged for usage based on execution time. Now, the real variable when it comes to pricing with Lambda is the amount of memory that you make available to it. And you can choose to have anywhere from 128 to 3008 megabytes allocated for your functions that are running on AWS Lambda. Now, the great thing is that it integrates with many AWS services just out of the box. For example, the work with things like S3 and DynamoDB is just automatic once you configure it. And because of that, it can enable what we would call event-driven workflows. So you could say something like, when I upload a file, I want you to execute this function. Now, this is the primary service in terms of compute for the serverless architecture approach, and we'll be talking more about serverless later within this path. Now, let's look at some advantages for Lambda. First of all, there are reduced maintenance requirements, so you don't have to worry about those underlying servers and keeping them up to date. In this case, AWS owns that for you. Also, it enables fault tolerance without you having to build it in. So this concept of running across multiple availability zones and making sure that no single point of failure can take down your application, well, that's just built into Lambda. Also, it scales based on demand. So irrespective of the number of users you have that are using your Lambda function, you can know that it will scale. And your pricing is based on direct usage. Whereas with EC2, if you have a server up and running, and let's say it supports 1,000 people and you only have 10 people using it, you're having to pay for that whole server. But with Lambda, it truly maps to usage because it's only going to charge you based on the usage that you have.
So next, we're going to talk about a different class of compute services on AWS, and that would be the container services. Now, Google defines containers as packages of software that contain all of the necessary elements to run in any environment, and containers virtualize the operating system and run anywhere, from a private data center to the public cloud or even on a developer's personal laptop. So think of it this way. We've already talked a bit about EC2. Now, if I wrote some very simple code, I could go in first, launch an EC2 instance, configure the operating system to have everything that I need to run my code, and then deploy my code onto that server and run it. But there's another way. With containers, I could package that operating system and all of its configuration and needed elements alongside my code, and then go to a service that knows how to work with containers and simply say, hey, run this. Well, let's look at some different container services on AWS and understand the differences between them. So first of all, if you're just getting started with containers and you don't have a lot of prerequisite knowledge about working with some of the more advanced options, we have AWS App Runner. And this is really focused on web applications or APIs that you want to deploy without prior knowledge of the infrastructure required to run containers. So that's one option. But maybe you're a bit more advanced and you want to look at a full-fledged service to run multiple containers. In this case, we would start to look at the container orchestration services. And when we're looking on AWS, we really have two here. First, we have Amazon ECS. And this really is a full-featured container orchestration service. You can look at deploying hundreds of containers and configuring all the specifics around how it actually scales to meet user demand. But we also have another solution, and that option is Amazon EKS. And this is based off of what really has become the industry standard for container orchestration, Kubernetes. So this is a Kubernetes-based full-featured container orchestration service. Now, we also have to choose how we handle the compute resources that are running our containers. And that's where we get to two different choices for compute engines for container orchestration. Now, as a note, you don't have to worry about this with App Runner, but when you're running ECS or EKS, you have to pick a compute engine that you'll leverage. The first is Amazon EC2, and we've already talked about this. So EC2 can indeed run your containers, but if you take this approach, you have to manage the entire scaling process, and you have to make sure that you have enough compute resources to meet whatever user demand that you have. But there is another option, and again, this works for both ECS or EKS, and that would be AWS Fargate. So this is what they call a serverless compute engine for use with container orchestration services. What this means is you don't have to manage rules around scaling. You don't have to manually say, hey, I need this many instances to run my containers. Behind the scenes, AWS is owning that, and then what they're doing is they're actually scaling to meet based on the user demand that your service is actually seeing. So how do you select a container service? Well, let's look at a few different points here to help understand what you would need to know for the exam. First of all, App Runner requires no prerequisite knowledge of containers or infrastructure. So if you're just getting started with containers, or maybe your team has never had a container-based deployment before, you could take a look at App Runner as an easy way to get going with containers in the cloud. Next, EKS provides an easier starting point for Kubernetes in the cloud. Now, you could completely create a custom deployment of Kubernetes, and you could go through and install all the different packages and set up all the needed servers, but EKS makes it easier. So if your organization says, we absolutely want to use Kubernetes in the cloud, EKS becomes a great choice. Now also, ECS natively integrates with many different AWS services. So if you are entirely focused on AWS within your organization and you're trying to select a container orchestration service and you're not already using Kubernetes somewhere else, then ECS might be a great choice. But also when we're thinking here about the compute engine, Fargate reduces the amount you have to manage and own for your container orchestration. So for many organizations, that's going to be the better choice. However, the EC2 approach provides maximum control for configuration of scaling when you're working with containers. So if you want to control every aspect of that container orchestration process, you might want to take a look at EC2.
So next, we're going to walk through 3 different scenarios that will help you gauge how well you have absorbed the information that we have presented within this module. So first of all, we're going to be looking at Sylvia, and her company is in the process of moving multiple workloads into AWS. And one of those workloads is an application that will be leveraged for at least 5 more years. This is just a core business application that her company will be leveraging for the foreseeable future. However, they're looking to be as cost efficient as possible for this EC2 usage. So for them, what EC2 purchase option should be chosen for the application? Okay, next we have Edward, and he's looking to deploy his PHP web application to a virtual server, but he doesn't have experience managing EC2 instances on AWS. He does need the ability to scale though, because he does think this application is going to be pretty popular. So for Edward, what is the best compute option for him based on this criteria? Okay, and now our third scenario. Cindy's company is transitioning to the cloud for its data processing workloads. Now, these workloads happen daily and can start or stop without a problem, so they're configured to handle that. The workload will be leveraged for at least 1 year. So for Cindy, what EC2 purchase option would be the most cost-efficient choice? So compute services are at the heart of any cloud platform, and we have introduced 3 different compute approaches on AWS in this module. So here's what we've gone through. First, we introduced Amazon EC2 and its capabilities. We also explored different pricing approaches for EC2 instances. Then we introduced the capabilities of AWS Elastic Beanstalk, as well as reviewing use cases for Elastic Beanstalk. And then finally, we introduced AWS Lambda. Now let's go back and take a look at the 3 scenarios that we presented in the last clip. So first we had Sylvia, and she was looking to move a workload over that was going to last for at least 5 more years, and her organization was looking to be as cost efficient as possible. So what purchase option should she choose? Well, in this case, we would look at an all upfront reserved for 3 years. In this case, we can maximize the cost savings by having a 3-year reserved instance and paying for it all upfront. Next, let's look at Edward. Now for Edward, he was looking to deploy his web application, but he doesn't have experience working with EC2 directly. So what should he do? So in this case, Elastic Beanstalk would be the best choice for Edward. Elastic Beanstalk supports PHP, and it also handles things like scaling out of the box, and it doesn't require manual configuration for that. So Edward could get pretty far by leveraging that platform. Now let's look at the third scenario. Here we're talking about Cindy's company, and they're transitioning to the cloud for its data processing workloads. And the question is, what EC2 purchase option would be the most cost-efficient choice? Well, you're looking at this here. You might be looking at the line that says this workload will be leveraged for at least 1 year and think, exactly. This is about reserved instances, but it's not. The solution here is spot instances. Why? Well, because this workload can start and stop without a problem. So anytime you see anything about starting and stopping a workload without a problem, and it's going to talk about the most cost-efficient choice, the solution is always going to be spot instances, because spot instances are by far the most cost-efficient way to leverage EC2. However, it can't work with an application that can't start and stop on demand. So in this case, spot instances would be the best choice for Cindy's company. So next, we're going to be talking through the content and network delivery services on AWS. And when we're talking about these services, we're really primarily talking about 6 different services. And that includes Amazon Route 53, Amazon VPC or Virtual Private Cloud, AWS Direct Connect, Amazon API Gateway, Amazon CloudFront, and Elastic Load Balancing. So over the course of this module, here's what we're going to be covering. First of all, we're going to be introducing the concept of virtual private clouds on AWS. And then we'll be understanding the purpose of AWS Direct Connect, when you would use it and why it's important. Then we're going to be examining DNS utilizing Amazon Route 53. We'll then be reviewing Amazon CloudFront, which we talked about briefly when we were talking about the AWS global infrastructure. And then we'll be reviewing API Gateway. And finally, we'll be introducing Elastic Load Balancing and some different scaling approaches on AWS. So next, we're going to be talking about Amazon VPC and Direct Connect. Now, when we're talking about a virtual private cloud or VPC, really what we're talking about is a logically isolated section of the AWS cloud. And this is where you can launch your EC2 servers in that area and know that it is just your slice of the cloud. And this is a virtual network that you define and you can configure. Now, when we're talking about VPC, there's a couple of things to note here. First of all, it does enable you to have a virtual network in AWS. Now, let me ease your mind for a minute. You don't have to be a networking guru to be able to pass your Certified Cloud Practitioner exam, but you do need to understand what a virtual private cloud is. But for those of you that want to dive a bit deeper, let me tell you that within a virtual private cloud, you can support both IPv6 and IPv4 addresses. And those are just different standards that we have for the addresses that our computers have on the networks that they're on. And you can configure an IP address range, subnets, route tables, and network gateways. Again, you don't have to know all of those details for the exam, but if this is an area of interest, you should know that you can configure all of these things within your VPCs. Now, in addition, it does support both private and public subnets. So if you want to have areas that can't communicate or can't be reached from the internet, you can do that. If you want to have areas that are accessible to the internet, for example, if you have a web server that you want to be available, you can do that here as well. Now, if you do have private subnets, you can use network address translation or NAT for those private subnets. And there are multiple ways that you can actually establish a connection to your data center. And we'll talk about one of those in just a minute. And you can connect VPCs to each other. So you can have what we call peering connections or use Transit Gateway to be able to connect multiple VPCs. You also can have private connections to many AWS services. Now let me explain why that's important. If you want to be able to make sure that your sensitive application doesn't have to send traffic through the internet, but can just stay within your VPC, there's a way to do that even when you're using specific AWS services. Now next, we have AWS Direct Connect. Now this is a service that makes it easy for you to establish a dedicated network connection from your data center to AWS. So let's say, for example, you have a business application that uses application data that's stored within your data center, but the application itself is running on AWS. Well, it would be ideal to have a high-speed connection between your data center and AWS directly, as opposed to having to send it through the internet. And that's what AWS Direct Connect provides for you. So next, we're going to talk about Amazon Route 53, and this is Amazon's DNS service. And we'll talk more about what DNS means in just a minute. But if you remember, we have already mentioned this service. This is one of the two services that leverage AWS's edge locations within their global infrastructure. But at a high level, Amazon Route 53 is a domain name service, as we mentioned, and it's also a global service, which we also had mentioned previously. That means that it is not a regional service. That means any changes that you make are applied globally. Next, it's highly available, which means this service is going to have minimal, if any, downtime. In addition to it being highly available, it enables you to create highly available services, and we'll actually give an example of that in just a minute. Next, it enables global resource routing. So you could actually send people to a specific server based on what country they're coming in from. Or, in addition, you also could say, I want to send them to the server that responds the fastest. Now, what is DNS? DNS is really just a process by which we can map domain names like pluralsight.com or amazon.com to the specific addresses that are needed for identifying the computer services and the devices that are going to serve that content. So this is the connective tissue between those domain names and those IP addresses. Now, when we look here at the console utilizing Route 53, As we've mentioned before, it is a global service and it does not require region selection. That means that any changes that you make here within the Route 53 console are applied globally. But you do need to know that DNS changes are not instantaneous. It does need to what we call propagate those changes throughout the network of DNS servers around the world. So it might take a couple of hours for some of your changes to be realized for everyone. So let's give an example of how Route 53 can enable you to have a highly available application. So in this case, we have an e-commerce site, and it is currently hosted in US East 1, which is in Northern Virginia. And we have users from all over the globe that actually leverage this site. Now in this case, we have a customer that's coming in from South America. And when they access the site normally, it's going to route them to US East 1, and everything works great. However, what happens if our server goes down in US East 1? Let's say we deploy a bad configuration and that actually goes down. Well, what do? Well, we can configure Route 53 to have a failover so that if it can't reach its primary server, it can then route users to a new server. In this case, we can route them to EU West 1, which is in Dublin. And in this manner, the user doesn't have to know that anything has changed, but we're now routing them to a server that can fulfill their requests because we have that failover in place. And that's just one of several ways that we can utilize Route 53 to create highly available applications. So next, we're going to talk about a service called Elastic Load Balancing. And this might be a term that you're familiar with because we did introduce earlier the concept of elasticity. And just as a reminder, it is the ability for infrastructure that's supporting an application to grow and contract based on how much it is used at a point in time. Well, one aspect of that is how we actually route users to the correct infrastructure, and that's where elastic load balancing comes in. So what elastic load balancing does in essence is that it can distribute traffic across multiple targets. So at a really high level, if we have users that are coming to our web application and we have two servers, it can choose to route the users between those two different servers based on the load of each of those servers. So by default, it will integrate with EC2, ECS, which we haven't yet talked about, but this is AWS's container service, so for running Docker containers, and Lambda. So it supports one or more availability zones within a region. So you could say, for example, we want to have our customer website running across 3 different availability zones, and we want to have servers that exist in each availability zone, and then we can leverage elastic load balancing to distribute users to the right servers in one of those 3 availability zones. Now there are 3 types of load balancers. We have application load balancers, or ALBs, network load balancers, which you'll hear called NLBs, and we have classic load balancers, and in some cases those will just be referred to as either classic or ELBs. Next, let's talk about the process of scaling, specifically with Amazon EC2. And we will be diving down into this quite a bit deeper in a later course within this path. But at a high level, we have a couple of choices when we need to scale our servers on EC2. So the first here is what we call vertical scaling. This is when you scale up. So note here that vertical scaling and scale up are talking about the same approach. We scale up our instance type to a larger instance type with additional resources. So let's say we were using a T3 medium instance type. And let's say that we just noticed that our users are hitting that server pretty hard and it's not responding as quick as it needs to, and it's even dropping the connection for some of our users. Well, that's not a good thing. We need to address that. And sure, we could go in and say that we want to get a larger server. We could do something like an M4 X large. But if we do that, we're going to have to shut our server down. And then we can add those additional resources to it by changing the instance type, spin it back up, and now we're able to meet our customer's need. However, that's usually not the best way. The best approach is what we would call horizontal scaling, or scale out. And again, remember here that horizontal scaling and scale out are talking about the same approach. This is where we leverage elastic load balancing, and we add additional instances to handle the demand of the application. So in that case, maybe we have a T3 medium server, and maybe then we just add 2 more T3 medium servers, and then we rely on horizontal scaling with the elastic load balancer to actually handle the process of routing our users to the correct server. Now, as I mentioned, in a later course within this path, we're going to tie this together with EC2 and talk about how you can leverage auto-scaling groups alongside elastic load balancing to make this work. So next, we're going to talk about 2 additional AWS services, and those are going to be Amazon CloudFront and API Gateway. Now, we've mentioned CloudFront before. This is a service that leverages the edge locations within the AWS global infrastructure. And it is a content delivery network, which means that there are servers around the world that you can send your content to. And why would you do that? Well, because it enables your users to get content from the server that's closest to them, which will increase performance. It also supports both static and dynamic content. Many people think about content delivery networks only serving static content like images and videos or even specific text, but in this case, you can also configure it to support dynamic content. Now, it also utilizes the AWS edge locations that we've mentioned, which we also noted were the most prevalent form of the AWS global infrastructure. It also includes several advanced security features, and those include things like AWS Shield, which handles distributed denial of service attacks, and their web application firewall. Now, within a later course in this path, we'll be diving more into security and understanding how that factors into your use of CloudFront. But just as a reminder, there are edge locations that exist globally. So this gives you the power to take your content and distribute it globally within just a matter of minutes. So next, let's talk about another service, Amazon API Gateway. Now, what API Gateway is that it is a fully managed API management service. This means that you can create APIs, which are just web services that then other applications can call, and you can make those available. And you can actually distribute those through CloudFront. It directly integrates with multiple AWS services, including several of the services that we have learned about so far within this course. It also gives you concepts like monitoring and metrics on your API calls so that you can understand how your APIs are being used and also debug them if they're not working properly. Now, you can also integrate this in with both VPC and on-premise private applications, so it doesn't just have to be for public API calls. So next, we're going to discuss a service called the AWS Global Accelerator. And according to AWS, this is a networking service that sends your users' traffic through Amazon Web Services' global network infrastructure, improving your internet user performance by up to 60%. Now, let's talk for a minute about how that's possible. So first of all, Global Accelerator, and one of the ways it's different from a solution like CloudFront, is that it does utilize IP addresses. And in this case, it still uses edge locations like CloudFront, but it's actually using it from IP resolution instead of DNS. So once the user reaches the edge locations, instead of routing traffic with a user request through the public internet, once they reach those edge locations, no matter where you're resolving it to, it's going to route that traffic through the AWS network and not the public internet. And it can route requests to many different AWS resources. And that includes things like a network load balancer or NLB, an application load balancer or ALB, or even just EC2 instances. Or maybe you've just assigned an elastic IP address to some type of AWS infrastructure. You could use that as well. Now let's talk about the different performance improvements that are possible with Global Accelerator. First of all, the distance between that user request and the initial endpoint is going to be minimized because it's using edge locations. Now, this is also true when you're using something like CloudFront. Traffic is going to be optimized by using the AWS network instead of the public internet with that IP-based resolution. And what this does is it does result in improvement in that first byte latency, the jitter, and the throughput. So overall, the request is going to be more efficient. And it does also provide superior fault tolerance by not relying on DNS resolution. And let me speak to this for just a minute. So with most solutions, what can happen is that we use a host name, and that host name, the IP address might get cached. So if you're using something like Route 53 for failover, what happens is that if the client remembers an old IP address and it needs to fail over to a new region, for example, in some cases, that switchover might not be seamless. But here, because of Global Accelerator, we are using IP-based resolution, so it is able to make that transition seamlessly. So let's talk about when you would consider AWS Global Accelerator, especially over a solution like CloudFront, because they are similar. First of all, if you're using a non-HTTP protocol, things like UDP, MQTT, or VoIP. So you might be using UDP in a gaming context or in a video audio type context. With MQTT, you might be leveraging this for IoT-based devices. and then VoIP if you're doing, again, internet telephony. Now, if we look at another use case, and that's going to be if you have a situation that requires a static IP and not a DNS-based resolution, then in this case, you're going to need to use Global Accelerator. Also, if you need instant failover with the highest level of high availability, then in this case, you would certainly want to take a look at the AWS Global Accelerator. So next, we're going to walk you through some scenarios so that you can see how you have mastered the content that has been presented within this module. So first of all, we're going to look at Jane, and her company maintains 2 different corporate data centers. And they want their data centers to work directly alongside AWS for specific workloads. So in this case, they probably have some data that's stored within their own data center, but they want to have some public applications on AWS, and they need to have those public applications to be able to communicate with their data center. And so she's wondering if there's any way to have a persistent connection to AWS, because she's worried about just sending everything out on the public internet, that could potentially be slow, and ideally she'd like some of this communication to happen kind of behind the firewall. So what service from AWS would you recommend that her company implement to meet these criteria? Okay, next we're going to talk about Tim. And we've met Tim before in a previous course. And his company is looking to serve content through their site to users all around the globe. And they're looking to optimize their performance to users around the world. Now they want to leverage a content delivery network. Now previously we asked what element of the AWS global infrastructure Tim would be leveraging. But in this case, we're going to get even more specific, and we're going to ask the question, which service would enable optimized performance globally for this company's content? Okay, we got one more scenario. Here, we're going to be looking at Ellen, and her company has an internal application that runs on an EC2 server. Now currently there is some downtime because demand is greater than capacity for the server. So for example, the server could probably handle about 150 users without fail, but in this case we have up to 200 simultaneous users. So this is a problem. So here, Ellen is trying to decide if she should use bigger servers, so in essence changing the instance type, or more servers, so more servers of the same kind that they already have. So which scaling approach, based on the ones that we've discussed, would you recommend for Ellen's company? And then what services should they use alongside that approach? So we'll cover these answers in the next clip. So we've covered a lot of new AWS services here within this module. Let's quickly give an overview of what we've learned, and then we'll dive into the scenarios that we discussed in the previous clip. So first of all, we introduced virtual private clouds on AWS. We also understood the purpose of AWS Direct Connect, which gives you that direct connection between your data centers or your office locations and AWS. We examined DNS with Amazon Route 53. We understood what DNS does and how Amazon Route 53 can help us build highly available applications. And then we reviewed Amazon CloudFront as well as API Gateway. And then finally, we introduced elastic load balancing and the different scaling approaches that you can take when you are leveraging it. Now let's look back at our scenario with Jane. So Jane's company has 2 different corporate data centers, and they're looking to have their data centers work closely with AWS. So what service from AWS would you recommend for her company? Well, in this case, AWS Direct Connect is a great fit. They can build direct connections between their data centers and AWS, which means that traffic does not have to go over the public internet. That also means that a lot of this communication can happen behind the firewall for them. Next, we're going to talk about Tim. And his company serves content through their site to users all around the globe. And they really are looking to optimize performance. And they want to leverage a CDN or content delivery network. So what service would optimize that performance globally? Well, in this case, this would be Amazon CloudFront. That is the content delivery network that is present on AWS. So anytime you hear a question on the exam talking about a content delivery network, think about Amazon CloudFront and how that could help the users that are leveraging that service. So next we have Ellen, and her company is running that internal application on an EC2 server, and they're having the downtime. So which scaling approach would you recommend? Well, in this case, we would recommend horizontal scaling or scaling out using elastic load balancing. This is preferable over using just bigger servers because it can handle whatever future load you can throw at it. However, if you get bigger servers, it's possible you're just going to have to take those servers down again and make them even bigger. We want to limit downtime, and we're going to do that by taking a horizontal scaling approach. And by using elastic load balancing, we can make sure that we are routing users to the best server for them to use. So next, we're going to be talking through file storage services on AWS. And that means that we're really going to be looking primarily at 6 different services. And these are going to cover both file storage, but as well as data transfer. And so first of all, we'll be looking at Amazon S3. And this is one of the core AWS services. And then we'll also be looking at Amazon S3 Glacier. We'll then be looking at Amazon Elastic Block Store, or EBS, Amazon Elastic File System, or EFS, as well as AWS Snowball and AWS Snowmobile. So that's what we're going to cover, but let's talk about how we're going to cover that within this module. So first of all, we will be reviewing the overall storage services that are available on AWS to help you understand the ecosystem. But then we will be doing a deep dive on Amazon S3 and its capabilities. Because it is a core service, it will be important to understand many aspects of this service. Then we'll actually be implementing a static website using Amazon S3. Then we'll be exploring the different archive capabilities that are present with both Glacier and Glacier Deep Archive. Next, we'll be looking at EC2 storage, and we'll be looking at that storage with both the Elastic Block Store and the Elastic File System. And then finally, we will be examining large-scale data transfer into AWS. So next, we're going to be talking about Amazon S3. And Amazon S3 is a core AWS service. It is the first service that I ever leveraged on AWS, and chances are, if you've leveraged the platform at all, you have used Amazon S3 at some point. Now, Amazon S3 at a high level lets you store files as objects inside of buckets. Now, buckets are the unit of organization within S3. You will create a bucket, it will have a set of settings, and then any file that you drop in can have those settings applied to it. Now, it provides different storage classes for different use cases, and we'll dive through those storage classes in just a bit. It allows you to store data automatically across multiple availability zones, which gives you durability and resiliency for your data. Now, another great feature of S3 is that it enables you to have URL access for your files. So if you want to be able to send a link to someone else to access a file within S3, assuming the permissions are correct, you can actually do that. And it also offers configurable rules for data lifecycle. So if you want something to expire after a period of time or go to a different storage class. Now, it also can serve as a static web host, and we'll actually be implementing that later within this module. So next, let's talk about the non-archival storage classes for S3. Now, as a note here, we will cover the archival storage classes later within this module. So first of all, we have S3 Standard. And by default, if you upload a file to S3, it will have the S3 Standard storage class. Then we also have S3 Intelligent Tiering. And this is a special storage class that will allow you to move your data to a correct storage class based on usage. And we'll talk more about intelligent tiering in just a minute. Then we have S3 Standard Infrequent Access. So if you have data that is not frequently accessed, you can get a lower cost by utilizing this particular storage class. Now, it still has the standard resiliency because it leverages multiple availability zones. But we also have S3 One Zone Infrequent Access. And this is for data that is not frequently accessed, but it is only stored within one availability zone. So you get a much lower cost point than you do with the other options. However, you do have less resiliency. So let's talk about intelligent tiering. Now, intelligent tiering is the only way that you can automatically move data between different storage classes based on access. And within this overall storage class, it has 2 different classes associated with it. The first is frequent and the second is infrequent. So it will move your data back and forth between those 2 different classes. It gives you pretty much the same performance as what you get with S3 Standard, but it can provide a cost savings if you have some data that needs to be moved between those different storage classes. Now next, let's talk about the S3 lifecycle policies. Now this is an approach that allows you to transition based on your own custom criteria objects in your bucket. Now transitions in this case can enable objects to move to another storage class based on time. Now it's important to note here, you can't move something back and forth based on usage. That's only available with intelligent tiering, but you can do it based on time. And you also can delete objects with expiration based on age. So if you want a certain file to only last for 30 days, for example, you could configure that also using lifecycle policies. Now, policies can also factor in the concept of versions for an object within the bucket. So S3 does support versioning of data, and you could say something like, for example, delete a version of a file that's not the current version after 7 days. So those are different things that you can configure utilizing S3 lifecycle policies. Now, one additional concept here for S3, and that is the concept of S3 transfer acceleration. So this is a feature that enables you to upload data into your bucket much faster, and it does it by utilizing the AWS edge locations as a part of Amazon CloudFront. So if you need to upload your data in a fast and efficient way into your S3 buckets, you can consider utilizing S3 transfer acceleration.
So next, we're going to put some of our knowledge to practice by actually hosting a website on Amazon S3. So here over the course of this demo, you will be first creating a new S3 bucket, then uploading objects to an S3 bucket, accessing objects from the S3 bucket from a URL, and configuring a bucket for website hosting. So let's dive in. So now I'm here in S3, and if you notice, we already have one bucket. And if you remember, earlier we utilized the CLI to create a bucket with the Cloud Shell. So that's the reason that this bucket is here. But for this example, we're going to go in and create a new bucket. So first, I'll go in and close the side panel to give us a bit more room, and I'll select the option for Create Bucket. Now from here, I need to give my bucket a name. Now it's important to note here that bucket names need to be globally unique, not just unique within your own account. So in this case, we'll have to give it a name that no one else is using in all of AWS. Now don't worry here, if you pick one that's already in use, it will give you an error and you can go in and specify another one. But here we'll delineate that this one is for our website hosting test that we want to run. Now I'm going to keep the default value for the AWS region, and for object ownership, I'll specify that we do have ACLs enabled. This will enable us to set permissions for the objects that we actually upload. And I'll need to talk next about the block public access setting. So here in this case, AWS by default says everything within the bucket is going to be private. So it wouldn't be available to the public to simply access via a URL. Well, since we want to actually use website hosting here and we want to make our objects available, I'm going to deselect this option, and I'll scroll down to acknowledge that I have deselected this option, which means that it's possible that the contents of this bucket could become public. Now it's important to note here, this does not change the permissions. This just gives you the opportunity to make something public in the future. I'll keep the default values here for bucket versioning and tags, but I'll specify here that we want the objects that we upload into this bucket to be encrypted. And we'll just say that we'll use the Amazon S3 managed keys. Now with that being said, and all those things in place, I can now hit Create Bucket. Now that we have our bucket created, I'll close the side panel again and we'll go into this bucket. And we can now upload files into the bucket. So I'll specify upload, and I'll go through and add files. I'm going to select the 2 files that were included in the exercise files for this module, and then I'll hit open. Now we could go through and set values for these specific files, not for the bucket as a whole. So for example, we could go in and we could change permissions, or we could go in and change properties. Now, in this case, I'm not going to change permissions yet. We'll do that shortly. But here we could go in and change our storage class, but we'll leave this at the standard storage class for now. Now we don't have to specify encryption here because we have specified that everything that gets uploaded into the bucket will be encrypted. So that will happen without us changing any of those values. Now with those things in place, I can now hit upload. Great, so now our files have been uploaded. So I'll head back to the bucket. And from here, I'm gonna go into the bucket and I'm going to look at this ps-logo.jpg file. So here, for this JPEG file, you can see that we do have an object URL. So I will copy this URL and I will open this in a new tab. Now, first of all, you can see here that it gives us an access denied message, and that's because we haven't given permissions for this to be available to just the public. So I want to go back here into the console, and we're going to go to permissions for this ps-logo.jpg file. What I want to do here is I want to hit edit, and I want to go down to where it says everyone public access. And we'll change this to say that we want to be able to read this file. And we'll have to say that we understand what these changes mean, and then I can say Save Changes. Great. Now that permissions change is in place, I'm going to go back to the tab where I had the access denied message, and I'll reload this page. And we can see, now we see the Pluralsight logo that's included in this pslogo.jpg file. So now I'll go back here to the console, and I'm going to go away from this PS logo file and back to the bucket itself. And I'm going to go here to the properties for the bucket as a whole. Now there's an option that we can enable, and that option is static website hosting. And so here we can see we have the static website hosting option, and I'm going to change that to enable. And we'll say that we want to host a static website, and we'll have to enter in a few values here. First, I'm going to specify that our index file is going to be called index.html. Now I could add in an error document. So for example, if somebody tried to go to page.html, which doesn't exist, it would show the error document instead, but we're not going to add that in right now. We also could add in redirect rules. So if we wanted to redirect index.htm to be index.html, we could configure that here as well. But we won't add in any of those values for now, but we will hit save. And here we can see if we scroll back down to static website hosting, we see that we now have a bucket website endpoint. So here I'll go ahead and copy this, and we'll open this up in a new tab. And the first thing we notice is that it gives us a forbidden message. Can you think of why that is? Well, it's because we haven't yet given permission for our index.html file to be accessible to the public. So I'll go back here under the bucket, we'll scroll back, we'll go under objects, and I'll go to my index.html file, and I'll go next under permissions. From here, we'll specify that we're going to edit our permissions, and we'll give read access to the object for everyone. I'll go ahead and accept the warning here, and we can now save changes. And now, if I were to go here back to my website URL, and if I were to reload it, we can see that it indeed loads the index.html page. And you'll notice here, we're not actually going to the index.html page directly, we're just going to the website endpoint. And the reason this is showing up is because when we set up our static website hosting, we said that default page, the home page, is index.html. So here, we've done quite a bit. We've gone through the process of creating and configuring an S3 bucket. We've uploaded 2 different objects into that bucket and configured their permissions. We've then configured the bucket to actually be a static website host, and we've verified that we can access those files to the URL that's generated. So sometimes we're not hosting a website. Instead, we're choosing to store data in the cloud because we need to keep it around in case we may need it in the future. And we would call this archive storage. And in this case, Amazon S3 supports archive storage with S3 Glacier, which provides 3 different storage classes that are differentiated by cost and retrieval time. So let's take a look at the 3 different storage classes that we have with S3 Glacier. First of all, we have S3 Glacier Instant Retrieval. And then we have S3 Glacier Flexible Retrieval. And then we have S3 Glacier Deep Archive. Now these 3 different types exist on a spectrum. And if we look here at the far left side of the spectrum, we have faster retrieval. And if we look on the right, we have slower retrieval. But that also means if we look on the left, we have higher cost. And if we look on the right, we would have lower cost. So let's talk next about retrieval times. So first, if you're using instant retrieval, you can retrieve your data in milliseconds. This is going to work like most of the non-archive storage classes on Amazon S3. But next, we have flexible retrieval. And this means you can configure your retrieval time to be anywhere from minutes to hours. But next, we have deep archive. And in this case, this has a retrieval time within 12 hours. So with this being said, let's talk about some different use cases that you may have based on AWS recommendations for each of these storage classes. So first of all, AWS recommends that instant retrieval would be used for things like medical images, or news media assets, or user-generated content archives. So in other words, we're not going to access this data all the time, but when we need to get access to it, we want to get access to it quickly. Then we have flexible retrieval. And in this case, this would be great for disaster recovery. Let's say, for example, we want to back up some core bits of data in case we ever have our primary data center that our company owns and maintains, it goes down. Well, we could use S3 as a backup or disaster recovery site. We also could use this for offsite data storage needs. Next, we have Deep Archive, and this is for long-term data storage, and this might be there to meet compliance requirements if we need to hold on to certain types of data for 7 to 10 years, or just in cases where the lowest cost is critical, and that's more critical than being able to access the data quickly.
So next, we're going to talk about Elastic Block Store, or EBS. But before we get too deep into EBS, let's take a look at some different approaches that we have for file storage within Amazon EC2. The first is Amazon EBS, which is persistent block storage for use within Amazon EC2, and that's what we're going to be covering within this clip. But the next option is Amazon EFS, or Elastic File System, which is a network file system that is designed for Linux-based workloads, and we'll be covering that within the next clip. So at a high level, EBS is block storage that's designed to be connected to a single EC2 instance, and it can scale to support petabytes of data and also support multiple volume types based on what you need. So let's quickly give a high-level overview of EBS. So first of all, it does enable redundancy within an availability zone. This way you can make sure that your data is durable. Now it also allows users to take snapshots of its data. So if you have data that you want to have on a drive attached to your EC2 instances, but you do want to periodically take backups of this data, EBS can be a compelling choice. Now it does offer encryption of its volumes, but it doesn't necessarily encrypt things by default. You do need to make sure that is a step that you take if you're leveraging EBS. It also provides multiple volume types, including general purpose SSDs, provisioned IOPS SSDs, throughput optimized hard disk drives, and cold hard disk drives. And we're going to review each of those volume types at a deeper level. So first of all, your general purpose SSD is a cost-effective type that is designed for general workloads. But if you have a more intense use case, you might want to take a look at provisioned IOPS SSDs. So this is a situation where you're looking at high performance volume, but you really need low latency. Now we also have throughput optimized hard disk drives, and this is designed for frequently accessed data. But if we have situations where we have less frequently accessed data, we might want to consider the cold hard disk drive volume type. So next, we're going to talk about Elastic File System, or EFS. Now, in a previous clip, we talked about Elastic Block Store, or EBS, as one approach for attaching storage to an EC2 instance. And here, this is going to be the other option. So here, for EFS, first of all, it's important to note that it is a fully managed NFS file system, and it is designed specifically for Linux workloads. Now, similar to EBS, it supports up to a petabyte scale, so we're talking here about petabytes of data. It also can store data across multiple availability zones, so you get some of that durability by default. Now, it provides two different storage classes, the first being standard, and the second being infrequent access. And it can provide configurable lifecycle data rules, so you can transition between those storage classes. Now let's quickly take a look at an example of how we could leverage Elastic File System, or EFS. So here you can see an example where we have two different EC2 instances, one in availability zone A and one in availability zone B. And in this case, Elastic File System is working across both of those availability zones and has a mount point within each availability zone. So unlike EBS, where we're targeting attaching a volume to a single EC2 instance, Elastic File System has an ability to be a network file system that you can attach to multiple instances at the same time. Now, if you're running Windows workloads on AWS, one option you need to be familiar with is Amazon FSx for Windows File Server. And it is a fully managed native Windows file system, as opposed to being a Linux file system like we saw with EFS. And it includes native Windows features, and this includes things like SMB support, Active Directory integration, and support for Windows NTFS. And it also utilizes SSD drives for low latency. So next, we're going to talk about how you actually get large amounts of data onto the AWS cloud, even if you don't want to put it over the public internet. And one of the ways that we can do that is by leveraging the data transfer services that are provided with AWS. Now, the first is AWS Snowball, and this is a service where you want to physically migrate petabytes of data onto the cloud. But if that's not enough, there is even another service called AWS Snowmobile, and this is a service if you physically want to migrate exabytes of data onto the cloud. So let's compare these two options. First of all, we have AWS Snowball, and it is designed for large-scale data transfer, and as we mentioned, it supports petabyte scale in terms of data. Now in this case, it is going to be a physical device that is delivered by AWS to your office location. And you can actually connect this to your network and then upload your data from within your network. Now when you return it, it's going to be returned by a local carrier back to AWS. And then when they get the device, they're going to load your data into S3. And so that's how AWS Snowball works. Now, AWS Snowmobile is a little bit more intense. First of all, it is also designed for large-scale data transfer, but in this case, it supports exabyte scale. Now, it is a ruggedized shipping container, and it is going to be delivered to your location. Yes, a shipping container like one that's pulled by a tractor-trailer truck. This is rather large, and this is for some more extreme type scenarios. Now, AWS will be there to set up a connection from your network to that shipping container, and then it actually loads your data onto the Snowmobile. And then AWS will work to be sure your data is then loaded into S3 when that shipping container is received back at AWS, and they can do multiple trips to get, again, exabytes of data. So next, we're going to talk through some example scenarios to see how well you've absorbed the material that we have presented within this module. And then in the next clip, we're going to be walking through the answers to these scenarios. So here is our first scenario. We have Elaine, and Elaine has launched a site that offers daily tutorials for developers, and she uses S3 to store the assets that are needed per tutorial. Now these assets are very popular within the first week that the tutorial is launched, but then, you know what, after this initial week, these assets are rarely accessed. So how could Elaine reduce her S3 costs while maintaining durability? Okay, next we have Esteban. And Esteban works for a social networking company, and they are moving to AWS. Now, as a part of this transition, they have about 2 petabytes of user-generated content that they need to migrate into the cloud. Now, he's trying to determine if there is a faster approach than uploading over the internet, because that is just going to take too long. So in this case, would there be another approach you would recommend for Esteban's company? Okay, finally, we have Emily. And Emily works for a company that produces a messaging app. And she's looking for a shared file system that'll connect to 8 different Linux EC2 instances. Now the file system would need to support 1 petabyte of data. So what approach would you recommend for Emily? Okay, we're going to run through the answers to these in the next clip. So we have looked at several different services over the course of this module that have to do with both file storage and data transfer. So let's quickly review what we've covered before we dive in and take a look at our scenarios. So first of all, we were able to review the different storage services that are available on AWS. As a part of that, we examined Amazon S3 and its capabilities. We also implemented a static website on Amazon S3. We then explored the archive capabilities within Glacier and Glacier Deep Archive. We reviewed EC2 storage leveraging both EBS and EFS. And then we also examined the large-scale data transfer services that are available on AWS. So now, let's review our scenarios. So first of all, we had Elaine, and she was trying to determine how she could reduce her S3 costs while maintaining durability. Well, what's the answer for her? Well, in this case, it would be to use S3 lifecycle rules with S3 standard infrequent access. So let's break that down. First of all, she could use S3 lifecycle rules, because in this case, the assets are only popular within a week of when they are released. So she could define a policy that would change storage classes for the data after 7 days of when they are placed inside of the S3 bucket. And then we could choose to leverage the S3 standard infrequent access storage class because that data is not frequently accessed. But we would want to stick to this storage class and not one zone infrequent access because we do want to maintain the durability of the data. Now next, let's look at Esteban. And so what approach would you recommend for him to get 2 petabytes of user-generated content into the cloud? Well, in this case, it's going to be AWS Snowball. Now, if we look here, we're looking at 2 petabytes of data. If we were looking at exabytes of data, an AWS Snowball wouldn't work. We would need to look at AWS Snowmobile, but because we're still dealing in petabytes, this would work just fine. So next we have Emily, and Emily was looking for a shared file system that would work between 8 different Linux EC2 instances and would need to support up to 1 petabyte of data. So what approach would you recommend? Well, in this case, it would be Amazon Elastic File System, or EFS. But note that there are a few conditions that need to be true before we can choose EFS. First of all, it needs to be for Linux instances, and in this case it is. Also, it needs to be in petabytes of data or less, and not in exabytes of data. So it seems like both of these criteria are met, and EFS would be a great candidate for Emily. Now we're going to be talking through the database services and utilities on AWS. And at a high level, the services we're going to look at are first Amazon RDS, and then Amazon Aurora, Amazon DynamoDB, Amazon Redshift, Amazon Elasticache, and the AWS Database Migration Service. Now it's important to note here that we're talking about several different types of services. So if we go back to our cloud computing models that we talked about in the previous course within this path, we talked about infrastructure as a service, platform as a service, and software as a service. And on the left with infrastructure as a service, this is the approach that gives us maximum control. But if we look at the option on the right, this is the option that gives us minimum maintenance. So if we look at this, if we want to take the infrastructure as a service approach to databases on AWS, we would just take an EC2 server and we would deploy our database onto it. So if you are a DevOps engineer, for example, and you want to have complete control over the OS that your database is running on, then you could utilize EC2 directly. However, maybe you want to have control over your database, but you don't need control over the underlying infrastructure. In that case, you could look to leverage Relational Database Service, or RDS. But then we'll also be talking about some different software as a service approaches that are available on AWS, like, for example, DynamoDB, Elasticache, and Redshift. So over the course of this module, we're going to be talking through these services. First of all, we'll be reviewing the cloud computing models for databases on AWS. And then we'll be introducing the Relational Database Service, or RDS. Then we'll be examining the capabilities of Amazon Aurora, which is one of the options within RDS. And then we'll be introducing the DynamoDB service. We'll then be reviewing the Elasticache service, and then finally examining how we do data warehousing on AWS. Now, another core service on AWS is the Amazon Relational Database Service, or RDS. And this takes a platform as a service approach to running databases that we can leverage within our applications that are running on the platform. So at a high level, within RDS, first of all, it's important to note that it is a fully managed service for relational databases. And it does handle core things like provisioning and patching, backup, and recovery of your database. These are all things that if you had to do it yourself, it would take a fair amount of time to implement this. And then to handle it at scale, it would take a fair amount of automation to integrate it in, and you get this by default when leveraging the service. Now, one of the great things about RDS is that it does support deployments across multiple availability zones. And it also supports read replicas for some of the platforms. That means you can actually scale out your databases. This can help you scale more efficiently within the applications that are leveraging this database. Now, it's important to note that when you launch an RDS instance, it does launch into a VPC, or Virtual Private Cloud. Now, we talked previously about EBS and different volume types. And here within RDS, we have 2 different volume types that are available to us. First of all, we have general purpose SSDs, and then we have provisioned IOPS SSD drives. Now let's talk about the different platforms that are supported within Amazon RDS. First of all, we have MySQL. In addition, we have Postgres, MariaDB, Oracle, SQL Server, and Amazon Aurora. Now, Amazon Aurora is an option that was actually created in the beginning to work on RDS. And it is a MySQL and Postgres compatible relational database that was built from the beginning for the cloud. And it combines performance and availability of traditional enterprise databases with the simplicity and cost effectiveness of open source databases. Now, you might be wondering, if you have a database that's running within your own data center and you want to figure out how to get your data into a service like RDS, how would you do that? Well, AWS helps you solve that problem too. So we have the Amazon Database Migration Service, or DMS. And what this enables you to do is to move your data into AWS from your existing databases. And it supports both a one-time and a continual migration of your data. And the great thing is it does support out of the box many both commercial and open source databases. And in this case, you only pay for the compute that you leverage in the migration process. So next, we're going to be diving in and taking a look at Amazon DynamoDB, which is a very exciting service on AWS. So first of all, it's important to note here what it is. It is a fully managed NoSQL database service. So fully managed in this case, this is a software as a service option. Not only do you not manage the underlying infrastructure, but you also don't even manage the database layer. You simply use the database. And in this case, it is not a relational database. It is a NoSQL database approach, which gives you some flexibility in terms of your schema, but also provides some other limitations depending on how you build your applications. And it provides both key value, and it also is a document database. And one of the great things about it is that it does enable extremely low latency at virtually any scale. Now you might be wondering how they were able to achieve that. Well, if you think about it, they have some great challenges to work with, including supporting Amazon.com. And so DynamoDB was built with that kind of scale in mind. And so they were able to build a database that could perform extremely efficiently at a very, very high scale. And it does support automated scaling based on configuration. So you can choose to have it scale based on the predicted need that you think you're going to have, but it can also scale automatically based on your usage. And there's also several other additional features like the accelerator, or DAX, which gives you an in-memory cache that you can use alongside the database. Now it can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. And so this gives you just the scale that you can't get with many other databases, and it's provided here in a way where you don't have to manage any of the underlying infrastructure. So let's talk through some of the use cases on when you might leverage DynamoDB. So here we have scale without excessive maintenance. Now, this is critical. If you have ever tried to scale a database in the cloud, it can be quite challenging. So if you have run up to an issue where you've had difficulty scaling, DynamoDB could be a great choice. Also, if you're embracing a serverless architecture, DynamoDB fits into that nicely because again, you're not having to manage any of the underlying infrastructure or even the database layer. Also, if you have implementations where low latency is key, you want to be able to get responses quickly from the database, DynamoDB is a great use case. But also, if you have data models without blob storage, so big bits of binary data within your database schema, if you have that, it's not going to work well with Dynamo, but if you don't, this could be a great fit. So next, we have two other managed services that you can leverage on AWS, and those are Amazon Elasticache and Amazon Redshift. So Elasticache is a fully managed in-memory data store, and it actually has two different engines that are supported, both Memcached and Redis, which are really the two most popular options you could choose within in-memory data stores. It provides extremely low latency in terms of response times, and you can include things like scaling and read replicas to meet your application demand. And again, you can do this without having to be able to manage that underlying infrastructure. It handles most common use cases, including things like database layer caching. So if you're working with another database, even something like DynamoDB, and you want to add a cache layer in between your application and the database, Elasticache can help fill that need. And even session storage. So if you're working with a web application that is doing session storage, you can utilize Elasticache with something like Redis to be able to get quick responses on session data. Next, you need to be familiar with Amazon Redshift. It is Amazon's born-in-the-cloud scalable data warehouse service. So if you're looking to do data warehousing for your user behavior data or for your analytics data, Amazon Redshift becomes a great choice. It supports petabyte scale, and in addition, it also leverages high-performance disks and column storage. So this gives you the ability to beat out many traditional data warehousing solutions because, again, this was designed with the cloud in mind. It does give you the ability to fully encrypt the contents of your data warehouse, and it does give you a level of isolation within your own virtual private cloud. Now, there are some great features that have been added to Amazon Redshift, including Redshift Spectrum, and this gives you the ability to query exabytes of data directly within Amazon S3.
So next, I just want to highlight 4 additional database services. Now, you won't need to know these at a deep detail, but it is important to know the names and know what use cases that you would utilize that database for. So let's review these really quick. First of all, we have DocumentDB, and this is a MongoDB compatible database. And MongoDB is a very popular database that already exists. And this is a service that AWS has provided that can mimic the API of MongoDB. We also have Neptune, which is a managed graph database service. And by a graph database service, this means it's mapping the relationships between different data points. And we'll talk more about that in just a minute. Then we have MemoryDB, which is a Redis-compatible in-memory database. So in some ways, this is similar to Elasticache in that it supports the Redis API. And then we also have TimeStream, which is a serverless time series database service. So let's dive in and talk a bit more about the use cases for each of these 4 database services. First of all, Amazon DocumentDB is ideal for organizations that are running some MongoDB workloads on AWS. So let's say you have a MongoDB database, you want to figure out the right way to actually build that on AWS. Well, one approach would be to utilize DocumentDB. Now, it doesn't have full MongoDB compatibility, but there are many areas where it is compatible. And next, we have Amazon Neptune, which, if you remember, I mentioned is a graph database. And this is ideal for mapping relationships between data points. So, for example, let's imagine that we built our own social network like Facebook, and we wanted to determine a list of friends for a specific user. And then we wanted to determine, well, the list of friends, for example. Well, this is the kind of thing that a graph database can do very well at because it's all about mapping those relationships. Next, we have Amazon MemoryDB for Redis, and it's ideal for a fast in-memory primary database. So if you want to be able to use that Redis API to be able to use it for a primary database. Now, we see Elasticache being used for different purposes, but here, if you need that for a fast primary database, you can use MemoryDB for this. Now, I should note here for the exam, I don't think they're ever going to make you decide between MemoryDB and Elasticache for using Redis in AWS. To be honest, that's a bit more of an advanced topic that wouldn't be covered at the cloud practitioner level, but it is important to know that MemoryDB does provide a Redis-compatible API. And then we have Amazon TimeStream, and this is ideal for storing and retrieving time series data points. So let me explain what I mean by that. Let's say that you have a temperature sensor on your house, and let's say that maybe you want to look at last Wednesday, and you want to determine what is the average temperature for last Wednesday. Well, you could go through and search for all the different data points that sensor reported for last Wednesday and then come up with an average. Or maybe you want to find out what was the highest point in the last hour for that temperature sensor. So in many cases, you'll see sensor data being a good use case for TimeStream because it's going to be capturing data at a specific time. And so that's just one example of how you could utilize Amazon TimeStream.
So next, we're going to run through a few scenarios to see how well you've done at absorbing the material we have presented within this module. And so the first scenario that we're going to look at has to do with Jennifer, and she is an IT executive in a financial services company. Now they're transitioning their data warehouse to AWS to take advantage of some of the great analysis features that are there, including some machine learning features they want to take advantage of in the future. Now their data warehouse would need to support up to 2 petabytes of data. So for Jennifer and her company, which approach would you recommend? And so next, we're going to be talking about Sam. And Sam is a DevOps engineer at a tech company. And he needs to launch a MySQL database for a new web application they're going to start building next month. Now in this case, because of some of their security needs, they need to have direct access to the virtual server that MySQL is running on. So what approach would you recommend for Sam's company? And so next we have Frank, and he is the CTO at a gaming company, and they are trying to determine how to store real-time user analytics. Now they need really low latency and the ability to scale to handle up to 1 million players for this new game that they're getting ready to launch that they know is going to be a hit. He also wants to minimize the amount of time it takes to maintain the database because in the past, they've worked with some very complicated databases to be able to get this level of performance. But in this case, he wants to look at AWS first for his solution. So which AWS approach would you recommend for Frank? So in the next clip, we're going to be walking through the answers to this scenario and take a look back at all the things we've covered within this module. So we have covered a lot in relation to databases and database utilities on AWS. So let's quickly take a look back and review what we've covered. First, we reviewed the cloud computing models for databases on AWS. We talked about how the concept of infrastructure as a service, platform as a service, and software as a service play out through the different database services that are available. We also introduced the Relational Database Service, or RDS, and we talked about Amazon Aurora, which is one of the specialty-made engines for RDS that was built by Amazon for the cloud. We then introduced the DynamoDB service. We talked about how it is a completely managed NoSQL database, and we talked about some of the unique capabilities that it provides. Then we reviewed the Elasticache service, as well as looking at data warehousing on AWS with Redshift. Now let's go back and take a look at the 3 scenarios that we introduced in the previous clip. So first of all, we had Jennifer, and she is an IT executive in a financial services company, and she has a need for a data warehouse in AWS. So what approach would you recommend? Well, in this case, the answer is going to be Amazon Redshift. This is the born in the cloud data warehousing solution from AWS. So if somebody asks you, what do you recommend for data warehousing on AWS? Redshift is going to be the best answer. And in addition, we need to look here and see that it is dealing with petabytes of data. Now, if we were talking about something like exabytes of data, Redshift Spectrum might be an ideal option to consider. Now, next we have Sam. And Sam was looking to launch a MySQL database for a new web application. So what approach would you recommend for Sam's company? Well, let me be honest with you. This is a bit of a tricky question. You might look at this and say, well, I know that MySQL is supported within RDS, so Sam should choose RDS. But here's the problem. Sam says that he needs to have direct access to the virtual server that MySQL is running on. So if he wants to manage that server directly, RDS can't be the solution for him. So in this case, we would be recommending EC2. And we would recommend this because he is wanting an infrastructure as a service option, which is going to be taking MySQL and installing it onto an EC2 server. Now, if Sam didn't need to manage the underlying infrastructure, we would certainly push him towards RDS, because many aspects of the platform would be managed for him. Now next, let's talk about Frank. And Frank needed a low latency database that could scale to handle up to 1 million users of the new game they're building. So, which AWS approach would you recommend for Frank? Well, in this case, DynamoDB is going to be a great choice. It can absolutely handle this level of scale, and it can also handle the low latency requirement. So many gaming companies have adopted DynamoDB for requirements just like this. So next, we're going to look at another category of services called App Integration Services. And when we're talking about App Integration Services, we're really talking about 3 distinct services on AWS. First of all, we're talking about Amazon SNS, or Simple Notification Service, which is a managed pub/sub messaging service. And don't worry, we'll dive into what that means later within this module. And then we have Amazon SQS, which is a managed message queue service. Now, both of these services together would also be known as the messaging services on AWS. But in addition to those two, we are also going to look at AWS Step Functions, and that is a serverless workflow management service on AWS. So here's what we're going to be covering as we go throughout this module. First of all, we'll be introducing Amazon SNS, Simple Notification Service, and introducing Simple Queue Service, or SQS. And then we're going to be exploring architectures that leverage SNS and SQS. Then after that, we're going to be examining AWS Step Functions, and we'll even have a chance to review sample AWS Step Function usage. So next, we're going to talk about the AWS messaging services. And the first one we're going to take a look at is Amazon SNS, or Simple Notification Service. And this is a fully managed pub/sub messaging service. And what this enables you to do is it gives you the ability to create decoupled applications. And we'll talk more in just a minute about what that means specifically. But the way it works is that it organizes information according to topics. So you can choose to listen to one topic and not listen to another. And that's what we mean by PubSub. It is publish and subscribe. So you can publish messages about, let's say, new orders, and then you could choose to subscribe to new orders and maybe order refunds. Now it integrates with multiple AWS services out of the box. And in addition to just providing messaging, meaning one part of your application can talk to another part of your application, you also can integrate this in and have end user notifications. So through this, you could send out an SMS notification or an email notification or a push notification to your mobile app. Now let's see some of this at work. So here we have a sample SNS architecture. Let's say that we're a software as a service company and we have a new user sign up. So we have a new user on our platform. We could choose to connect that process to an SNS topic. And let's say the first thing that we want to do is we want to integrate them into our CRM tool. Well, in that case, we could choose to connect that to a Lambda function that would then talk to our CRM and put their data in there. Let's say that we also want to have a queue for some of our salespeople to follow up with them directly. Well, we could use an SQS queue for that, and we'll talk more next about how you leverage SQS queues. But let's say we also want to send out an email so that the regional sales director in that area knows that, hey, you have a new customer that's come into the platform. We could also do that through SNS. But SNS works a little bit like some of the social networks that send out messages that then disappear. In this case, if we aren't listening for a message when it's published, we are not going to get it. These messages aren't kept around, they're short-lived. However, there's another approach we can look at, and that is leveraging Simple Queue Service, or SQS. So this is a fully managed message queue service, and it also enables you to build decoupled applications, but it also enables you to build fault-tolerant applications, and we'll look next at how that works. It supports a decent amount of data. You can put about 256 kilobytes into a message, and it allows messages to be stored for up to 14 days. So while we're thinking about SNS being more like some of those new social media apps that enable you to just send messages and then they disappear, SQS is a little bit more like a mailbox. Those messages will stay there until you actually go and get them out of the mailbox. Now there are two different types of queues that are included with SQS. Now a standard queue does not guarantee the order of the items that you're going to be pulling off of the queue. But if you use a first in, first out queue, it will guarantee that you're actually processing those messages in order. Now let's begin to see what happens when you put together SNS and SQS into an architecture. So first of all, we're going to have a user order, and this is going to come into our e-commerce company. And the first thing we're going to do is we're going to send that through an SNS topic. Now we're going to do something here called fan out. This is one of the benefits of using an SNS topic is that we can actually send messages out to multiple places. The first place we're going to send it is we're going to send it to a fulfillment queue. So this is going to connect to a server that we have in our warehouse, and this is going to be our order fulfillment service. And so our order fulfillment service knows to go and get a message off of the queue and then send that out so that we know what we need to put in the mail to send to our customers. But we also have another queue, and this is where the fan out happens. So coming from that SNS topic, we're now sending out to multiple queues. The next queue is our analytics queue. And this is where we want to be able to store the information about the products that we're sending out to customers. And we want to eventually be able to pull this into our BI tool so we can see trends for our products. So to drop this into our data warehouse, we have a Lambda function on AWS that's going to drop that information into our data warehouse tool. But something happens. We actually send out an update to our analytics integration service and it goes away. It doesn't work. Now here's the great thing. While that's not working, we're still loading up items into the queue. We haven't lost any information. And the moment that that service gets back up and running, it will be able to go and grab messages off the queue and put it into our data warehouse. This is what we mean by fault tolerant, is that we can have an aspect of our system go down and it can still work according to its purpose. But let's say we also have something else happen, and the same day, that server that's sitting in our warehouse just dies. The hardware itself goes kaput? Well, in this case, we're also still able to get orders in through our fulfillment queue. And the moment we get both our analytics ingestion service and our order fulfillment service back up and running, we will continue with our normal business processes without any lost data. So now we're going to talk about AWS step functions. And here's a few things that you need to know about AWS step functions. First of all, it enables orchestration of workflows through a fully managed service. And it does this in a way that supports serverless architectures. So this is one of the services that really enables this serverless mindset, where you're trying to limit the amount of actual infrastructure that you have to own and maintain. Now, it also can support very complex workflows, including error handling, and we'll see in a minute how you define those workflows within the service. Now, you're charged per state transition along with any of the other AWS services that you leverage. Now, in this case, that might sound strange to you, but here's what that means. If you have 4 steps in your workflow, you're going to be charged for each transition from one step to another. And then if that's running on a service like Lambda, you'll be charged the normal rates for the Lambda services that you're using. Now, workflows are defined using something called Amazon States Language. And you don't need to know how to write States Language at all, but I want to give you an example of how some of this would be defined. Now, let's say here that we wanted to get user signups, and we wanted to do some things simultaneously. After we get the sign up, we want to insert the data into our CRM, and then we also want to send them a welcome email. And then when we get done with that welcome email, we want to schedule a call with one of our salespeople. Now, once all of that's done, we want to wait a week, and then we want to send another follow-up email to see how they're doing. This is an example of what you can accomplish utilizing a step function on AWS. And you see a very small portion of how that's defined on the left. This is using a format called JSON to define the Amazon States Language. And this is what allows us to define the different steps within the workflow. Now, as I mentioned, it does have a lot of integrations in to other AWS services. So we have, for example, compute services, like integrating with Lambda, for example. It also can integrate with database services like DynamoDB, which we'll talk more about later within this course. It also can integrate in with the messaging services, meaning SQS and SNS that we have just talked about. Also, data processing services and even machine learning services. So this is a powerful tool that you can use to build out very complex workflows and have Amazon manage the state for you of the different steps within that workflow. Now next, we're going to walk through some scenarios to see how well you've absorbed what we have covered within this module. So our first scenario has to do with Ruth. And she started a nonprofit that assigns volunteers to open opportunities to serve. And recently, their database server went down. So when users went to sign up, it wouldn't let them do anything. So they actually lost some people that could have volunteered for some opportunities. Now, while they have improved their database server, they're still not able to guarantee that there won't be downtime in the future. So she really wants to explore an AWS service that could prevent these lost user signups. So in this case, what service would you recommend to Ruth? Okay, next, we're going to talk about Jessie. And she created a list of onboarding steps for new customers for their app. Now, these steps have a lot of integrations with things like their CRM. They want to send out an email to users. They want to integrate this in with analytics. Now, Jessie's a bit worried that it's going to take her development team a long time if they have to build all of this from scratch. So is there an AWS service that can help with this approach? Okay, let's look at our third scenario. And this one has to do with Roger. And his company is an e-commerce company that's building a custom e-commerce platform. So they're not using one of the ones off the shelf. Now, they're still adding some new functionality into their platform. And he wants aspects of the platform to listen for some key events like orders and refunds. But they don't yet know all the elements that need to respond to the events because they're still building it out. So is there a service that would allow current and future parts of the platform to listen for events like these? So here in the next clip, we're going to walk through the answers. So we have covered 3 different app integration services here within this module. So before we go look at our scenarios, let's quickly review what we've covered. So first of all, we introduced Amazon Simple Notification Service, or SNS. And we talked about how it enabled you to either publish messages to a topic or subscribe to get messages from that topic. We then looked at Amazon's Simple Queue Service, or SQS, and we talked about how in many ways it worked like a mailbox. You can put messages in and it will keep them there for up to 14 days, and this will help us build fault-tolerant applications. We also explored architectures that leverage both SNS and SQS. And after that, we examined AWS step functions, and we reviewed how you could take a very complex workflow and define it within a step function. So now let's take a look at our scenarios. So our first scenario was Ruth, and her nonprofit was losing volunteer signups because their database server went down. So what is Ruth really trying to solve for here? Well, she's trying to solve for being fault tolerant, because right now they're not fault tolerant. They're losing data with user signups. So what service would you recommend? Well, that's going to be Simple Queue Service, or SQS. This way, they can take user signups even if their database server is down, and when their server comes back up, it can simply go pull messages off of the queue. Next, let's look at Jessie, and she had the complex list of onboarding steps. So is there a service that she could use to model these steps? Well, in this case, that would be AWS Step Functions, because she could go in and take all the steps that she has in her onboarding process and integrate them into a workflow where every time there is a new customer, you could send them through that workflow with step functions. Now, last, let's look at Roger. And his e-commerce company was building that custom platform, but they don't know all the different components and what messages they're going to need to listen to. So they want to get a service that would allow for both current and future parts of the platform to listen for those key events. Well, in this case, that would be Simple Notification Service, or SNS. In this way, certain parts of the platform could listen for order events, and other parts could listen for refund events. So next, we're going to be talking about management and governance services. And when we're talking about this category, we're primarily talking about 6 different services. First of all, we have AWS CloudTrail, and then AWS CloudFormation, Amazon CloudWatch, AWS Config, AWS Systems Manager, and AWS Control Tower. So over the course of this module, here's what we're going to cover. First, we're just going to be reviewing the ecosystem of services that are provided for management. While we've looked at a lot of services that we can launch, this is where we transition to looking at what do we do once we launch resources within the cloud. Then, we're going to be examining how to create an audit trail by leveraging AWS CloudTrail. And then, we'll be exploring how you track infrastructure with both CloudWatch and Config. Then we'll be looking at a concept called infrastructure automation, or infrastructure as code, with CloudFormation. And then we'll be looking at operational insights utilizing Systems Manager. And then finally, we'll be reviewing AWS organizations, which is a concept we have already explored, but we'll be looking at how that works with Control Tower. So next, we're going to talk about a service called AWS CloudTrail. And according to AWS, CloudTrail is a service where you can log, continuously monitor, and retain account activity related to actions across your AWS infrastructure. Now, one of the great things about this is no matter which interaction method you're using, whether that's the console or whether you're using the CLI or whether you're working within the SDKs, CloudTrail is going to log all of those actions. So when we look at CloudTrail, first of all, you need to know that it includes this information into an S3 bucket, or you can even utilize CloudWatch, which we'll talk about later within this module. And it logs events in the regions in which they occur. Now, one of the good things about CloudTrail is that it meets many different compliance requirements for infrastructure auditing. So in terms of even just general best practices, you want to know who is initiating actions that change your infrastructure. But for some of you, you might be in environments where that's not just a like to have, that is a requirement based on different compliance standards. And for many of those standards, CloudTrail will meet that. Now, as a best practice, it should be enabled on every AWS account. Now, if you have your own personal development account and you're the only one that has access to it and you don't want to deal with the cost of storing this information in S3, you could choose to forego it. But for any other situation besides that, you want to be sure that this is turned on. And you can consolidate this. So if you are using AWS organizations, you could utilize the organizational trail to get information across all of your accounts. Now let's talk about some general use cases for using CloudTrail. First of all, and we've alluded to this already, it might be a compliance requirement. So if you want to be able to track information specifically for compliance purposes, CloudTrail can meet that. It could be that you're using this for forensic analysis. So if you have already had a data breach and you want to go back and see what actions were taken against infrastructure, you could utilize it for that. Also, you could use it for operational analysis. So if you're looking to determine who potentially changed infrastructure that caused a crash or caused an outage, you could go in and analyze the users that perform that and then work with them to make sure that that action isn't taken again. You also can do it generally just for troubleshooting. So you could go back and look at when a specific bad configuration was injected into the system and use that to fix any issues that are happening within your infrastructure. So next, we're going to look at two services, Amazon CloudWatch and AWS Config, that help you manage your infrastructure. But let's quickly take a step back and look at all of the services that enable you to manage your infrastructure. And the first of these that we have is Amazon CloudWatch, and this provides metrics, logs, and alarms for your infrastructure. Then we have AWS Config, and this continually evaluates your infrastructure against a predefined set of rules. Now we'll be covering both of these within this clip, and the next option is AWS Systems Manager, and it provides operational data and automation across your infrastructure, and we'll be covering that within the next clip. Now, these are not the only services that help you manage infrastructure on AWS, but these are the ones that you will need to know for your Certified Cloud Practitioner exam. Now let's first look at Amazon CloudWatch. So it is a monitoring and management service, and there are several different facets to CloudWatch. So it collects logs. So for example, if you have log messages coming from your custom applications, this can actually collect those logs. It also gets metrics. So you could have metrics being the number of users that are visiting one of your load balancers, for example. Or you can even get events that are coming from most AWS services. And it truly is a first-class citizen in AWS, which means that most services integrate with CloudWatch by default. But one of the powerful features is that it enables alarms based on metrics. So most all of the clients that I work with, we go in and set alarms so that if something is down or not performing as it should, CloudWatch lets you know, as opposed to you having to go and find that out yourself or have your customers tell you. So next, it provides visualization capabilities for metrics. So if you want to have a chart that shows a metric over time, that's part of what is included with CloudWatch. And because of that, you can create custom dashboards based on the metrics that it collects. So here's a sample dashboard where you can see some of this in use. You can see here that it's tracking things like CPU utilization on some EC2 servers and network traffic, and EBS activity for Elastic Block Store. And so this is just an example of some of the types of data that you can put into a custom dashboard. But next, let's talk about another service, and that's AWS Config. So AWS Config continually monitors and records your resource configuration, and it uses this so that you can evaluate that against the desired configuration. So let's look at how that works. So here within AWS Config, first of all, is it does provide a level of configuration history for your infrastructure. And it's also going to take a look at a set of rules. Now these rules, there are many that are included within AWS Config. In addition, you can also customize the rules that are there, or you can even create completely new ones. Next, it includes conformance packs for compliance standards, including things like PCI DSS. Now that is a standard that if you're going to be accepting payment information, you need to be able to meet this criteria. And to do that, you can follow the rules that are already in place within AWS Config to be sure that the infrastructure that you have is compliant. Now Config can also work within an AWS organization to look at all of your regions as well as all of the separate accounts that you have. And one of the great things about it is that it also provides remediation steps. So if your infrastructure doesn't meet some of these standards, it will give you insight on how you can fix that. So next, we're going to talk about the third service that provides resources for managing infrastructure within AWS, and that is going to be AWS Systems Manager. Now, Systems Manager provides this unified user interface so you can look at operational data from multiple AWS services. And for many of those services, you can even automate some operational tasks across those resources. So let's look at AWS Systems Manager at a little bit of a deeper level. First of all, know that it provides multiple tools that makes your life easier when you're managing infrastructure on AWS, and we will not be reviewing all of them, but we will touch on a few of them. First of all, it can enable you to automate tasks for common maintenance actions. Let's say that you have 2 applications in your AWS account that you're supporting. Let's say you have 10 servers that support one application and 10 servers that support another. And you want to update those EC2 instances for your first application with a new version of a library. You can actually write that action one time and then simultaneously send it out to all the servers that need to receive it. And then you could choose to have it update on those servers, but not have it affect the other servers at all. That's just an example of how you can use this automation capability. It also gives you a secure way to access your servers using just your AWS credentials. So if you don't want to have to deal with separate keys or separate passwords, you can utilize this approach for accessing those servers. Another thing is that you can store commonly used parameters securely for operational use. So let's say that you have a specific database password and you don't want to store that with each of your applications, but you want your applications to securely access that password when they launch. You could utilize Systems Manager for that. Next, we're going to talk about AWS CloudFormation. Now let's say for a minute that we have a custom application, and this custom application requires 2 S3 buckets, 5 EC2 servers, 2 SQS queues, and 3 Lambda functions. Well, we could go in and set up all of that in the console, but that creates a problem. There are a lot of manual steps that need to happen to make that work. And what happens if we miss one of them, or we incorrectly apply settings to a resource? Well, CloudFormation exists to solve this problem, and let's talk about how it works. First of all, it is a managed service for provisioning infrastructure based on templates. So, instead of going in and manually clicking in the console, or instead of writing a custom CLI script, or instead of going in and using the SDK to write your own custom logic for creating your infrastructure, here you're going to use a service that manages that for you. Now, there is no additional charge for CloudFormation. So with CloudFormation, you only pay for the resources that you launch, but the service itself does not have a charge. Now, you can write these templates in 2 formats. One is YAML and another is JSON, and those are both common formats, and many different tools can support the writing of YAML or JSON templates. Now, this enables an approach that we call infrastructure as code. This means that we're able to write a template that every resource on our team can use to launch infrastructure. And this means that we're taking the manual processes out of the picture. It also handles the management of dependencies between resources. So if we require one resource to be in place before we launch another one, it will go through and manage those dependencies. Now, one of the powerful features that you get with CloudFormation, and this is going to be similar to what we've seen in services like AWS Config, but this is specific here to CloudFormation, is that it provides drift detection. So if we launch our application that has all of those resources I mentioned earlier, but somebody goes in and changes the S3 permissions to be globally available, then in that case, we can notice that change and we could choose to take action. Now, here's a very quick and limited example of what we can do. So this is a YAML-based template, and with this information included in the template, if we ran it through CloudFormation, it would create an S3 bucket for us, and it would have the name sample-s3-bucket. Now, this is a very simple example, but you can expand to have very, very large templates. You can even have kind of templates within templates that enable you to launch infrastructure. So if you have a set of infrastructure, like I mentioned earlier for our custom application, you could launch that within one account and then turn around and launch it within another account. You could have one environment for production and another environment for testing and make sure that the 2 of those were completely identical because they're both based off the same template. And that's what you get with CloudFormation. So next, we're going to discuss another approach for managing your infrastructure on AWS, and that is going to be AWS OpsWorks. Now, OpsWorks is a configuration management service, and it provides managed instances of both Chef and Puppet. So if you're already using either Chef or Puppet, OpsWorks might be something that you want to take a look at. Now, if you're not familiar with Chef and Puppet, don't worry about diving into those to prepare for the exam. Next, your configuration is going to be defined as code for the servers that you're going to deploy it onto. And Chef and Puppet are going to manage the lifecycle of those configuration changes with your servers. Now, one of the things to note about OpsWorks is that it can work in a hybrid cloud architecture. So you can utilize it if you want to manage your deployments both in the cloud as well as within your own data center. Now, OpsWorks itself is really made up of three separate subservices. First, we have AWS OpsWorks for Chef Automate. And so here, this is your configuration management service that utilizes Chef Automate. Then we have AWS OpsWorks for Puppet Enterprise. So if you want to have a fully managed service that utilizes Puppet Enterprise, this would be for you. And next we have AWS OpsWorks Stacks. And this is what enables you to go in and define your application in layers. And then you can actually manage that using Chef recipes with Chef Solo. So depending on what you would be looking to do, you would choose the specific subservice that matches the stack that you're working with. So next, we're going to revisit a topic that we've already covered here in this learning path, and that is AWS organizations. But we're going to talk about it in light of another service called Control Tower. So quickly, let's revisit AWS organizations. First of all, it allows organizations to manage multiple accounts under a single master account. And it provides organizations with the ability to leverage consolidated billing for all accounts. That way, you only get one bill, even though you might have 112 different accounts. And within that bill, you can see your charges segmented by account. Also, it enables organizations to centralize logging and security standards across accounts. And really here, we've talked a lot about what AWS organizations is, but we haven't talked a lot about how you can properly use it. And many organizations in the beginning were implementing these multi-account strategies, and they found that it could get pretty complex. So AWS has a service called Control Tower. And this is a service that is designed to create this multi-account environment on AWS, and it follows their best practices in operational efficiency, security, and governance. So let's take a look at Control Tower. So here within Control Tower, first, it centralizes users across AWS accounts. And in this way, you don't have to go through and say, well, Ed can access this account under this username and then this other account under a different username and have to manage all of that complexity. In addition, it provides a way to create new AWS accounts based on templates. So maybe you have some specific things that you want to be sure are in every single AWS account that your development team uses. Also, it includes guardrails for accounts, so preventing accounts from doing some things that they shouldn't do. And it also includes a dashboard to gain operational insights from a single view. So you don't have to go log into every single account for certain pieces of information. You can see a lot of this centralized when you're using AWS Control Tower. So next, we're going to talk through three different scenarios that will help you gauge how well you're doing at absorbing the information that we have presented within this module. So here in our first scenario, we're going to be looking at Elliot, and he is an operations engineer at a financial services company. And he recently, by chance, discovered that someone had disabled a key security setting on a server. Now he's really concerned that events like this are going to go undetected. There's no way to know about them, and he's afraid they're going to have a data breach, and then it's going to become a huge deal. So for Elliot and his company, which service would allow the organization to continuously track configuration of infrastructure? Okay, next we're going to be talking about James. And he is the lead architect at a SaaS company, a software as a service company. And they're going to be launching a new application that includes several components. It has some EC2 instances, some Lambda instances. It's also going to have some S3 buckets and some SNS topics and SQS queues. And he's looking to minimize the manual work that is required to create this infrastructure. So they're going to be launching dev environments and prod environments and testing environments, and they don't want to have to do this manually every time. So what service would enable James to automate much of this effort? Okay, our last scenario here has to do with Candace, and she is the CTO at a manufacturing company. And a cloud server that was needed to support their manufacturing process was accidentally deleted. Now they've managed to fix that issue, but they want to follow up with the individual that accidentally deleted that server so they can help them know how to not do that next time. So if they wanted to figure out who this individual is, what service would they leverage so they can go back and find out who performed this action? So in the next clip, we'll be walking through a summary of what we covered in this module and looking at the answers to these scenarios. So we have covered quite a bit within this module as we have looked at management and governance services on AWS. So let's quickly just take a look at what we've been able to cover. First of all, we reviewed the ecosystem of services that are provided for management of infrastructure on AWS. We then looked at how to create an audit trail utilizing a service called AWS CloudTrail. And then we explored how you track infrastructure utilizing services like CloudWatch and Config. And then we introduced infrastructure automation with CloudFormation and this concept called infrastructure as code. We then were able to look at operational insights with a service called Systems Manager. And then finally, we reviewed the capabilities of AWS organizations when you are leveraging Control Tower. So now let's take a look at our scenarios. So here in this first scenario, we had Elliot, and he was concerned that some of these changes on servers might go undetected until there was a data breach. So what service would allow him to continuously track the configuration of infrastructure? Well, in this case, this would be AWS Config. And they could make sure that there is a set of rules enabled on Config that checks for the settings they care most about. Now next, let's take a look at James. And James was the lead architect at a SaaS company, and he was looking to minimize the manual work required to spin up new infrastructure for their new application. So what service would enable James to automate much of this effort? Well, this is going to be AWS CloudFormation, because here, James and his developer team could go through and create templates, and these templates could be launched with CloudFormation, which would manage that infrastructure. So next, let's talk about Candace. And Candace is the CTO at a manufacturing company, and she was looking again to find out who deleted one of their production servers. They know it was an accident, but they want to be able to follow up with that resource. So what service could she use? Well, in this case, this is going to be AWS CloudTrail, because it is going to provide an audit trail of actions performed on AWS, irrespective of whether or not they were done with the console or with the CLI or with one of the SDKs. So we've gone through a lot here in this course. There's a lot of AWS services that have been introduced here. So what do you do next? Well, first, I want to encourage you, don't sign up for the exam just yet. Wait until you make it through all 4 video courses, and later within this path, we'll walk you through the process of how you sign up for the exam and ultimately how you take the exam. Now, with this being said, you'll need to move on to the next course, which is an introduction to security and architecture in AWS. But what you need to study from this course is all of the material that's contained within first the guided notes that you took over this, and be sure that you thoroughly study the services list that we've provided for this course, because that information is definitely going to be on the exam. And as you'll learn later, I even recommend that you take the service list from this course and from the next course, and that's the last thing you look at before you walk in and take your certification exam. So I'm excited for you to move forward and take your next step and complete this learning path so you can take your AWS Certified Cloud Practitioner exam.